We look at the stars and we see beauty, we see opportunity, we see a vast, endless ocean waiting to be explored. But we are naive. If you talk to the astrophysicists, the ones who spend their nights staring into the mathematical abyss, they don't see an ocean. They see a minefield. There are numbers in the equations of our universe that shouldn't be there. There are silences in the sky that are too quiet to be natural. And there are monsters hiding in the laws of physics themselves, waiting for a single mistake to erase us. Tonight, we're not talking about ghosts. We're not talking about conspiracy theories. We're talking about the 7 scientific certainties that keep the smartest people on Earth awake at night. The things they don't tell you in school. The things they whisper about in the hallways of universities. Welcome to the reality you were never meant to understand. And be warned, once you know these theories, the night sky will never look the same again. There is a very old, very dangerous proverb that has echoed through the halls of human history for thousands of years. It is a phrase we print on the walls of our grandest libraries. We etch it into the stone foundations of our universities. We teach it to our children before they can even read. We tell them that the truth shall set you free. It is the guiding principle of our entire civilization. We believe, with absolute, unshakable religious fervour, that knowledge is power, and that ignorance is a cage. We believe that to see the world clearly, in high definition, stripped of all comfortable illusions, is the highest virtue a human being can achieve. We chase the light of understanding like moths chasing a flame, but we are wrong. We are catastrophically, heartbreakingly wrong. The truth does not always set you free. Sometimes, the truth is a weight that crushes you into the dust. Sometimes the truth is a blinding radioactive light that burns out your retinas and leaves you stumbling in the absolute dark for the rest of your life. And sometimes, the truth is a predator. We live our entire lives inside a bubble of comfortable, necessary illusions. We wake up in the morning, we drink our coffee, we go to work, we pay our taxes, we fall in love, and we tell ourselves that the universe is a stable, rational, and perhaps even caring place. We tell ourselves that we matter. We tell ourselves that there is a plan, or at least a structure, to the chaos around us. This illusion is not just a comfort, it is a biological necessity. It is a survival mechanism. If the human brain truly understood the precarious nature of its own existence, if it truly comprehended the sheer scale of the void that surrounds us, or the fragility of the atoms that bind us together, it would simply shut down. We evolved to hunt and gather on the African savanna, to navigate small tribes, to find water, and to avoid predators like lions and snakes. We did not evolve to stare into the heart of a black hole. We did not evolve to comprehend the collapse of vacuum energy or the silence of a dead galaxy. Our brains are designed to filter out the horror of the infinite, to reduce the cosmos down to a manageable size so that we can function without screaming. So, nature gave us a gift, the greatest gift a sentient species can receive, the gift of ignorance. The ability to look at the night sky and see pretty twinkling lights instead of nuclear furnaces burning in a graveyard of infinite cold. The ability to walk down the street without realizing that the ground beneath our feet is spinning at 1,000 miles an hour while orbiting a ball of fire that could sterilize us in a microsecond if its magnetic field flickered for just a moment. But science is the process of stripping away that protection. Science is the act of tearing down the walls of the nursery to see what lies in the forest outside. And for the last few centuries we have been tearing down those walls with reckless abandon. We have been so obsessed with the question of can we know that we never stop to ask should we know. There is a concept in philosophy and information security known as an information hazard or an info hazard. It describes a piece of information that is dangerous not because it is physically radioactive or toxic or sharp, but simply because it exists in your mind. It is a thought that harms you just by being thought. It is data that damages the hardware of your brain. Usually we talk about info hazards in the context of computer viruses that crash systems, or psychological triggers that induce trauma. But the universe has its own info hazards. There are theories in physics and cosmology that act like mental viruses. They are ideas that, once you understand them, once you truly internalize their implications and let them take root in your subconscious, you can never unknow them. You cannot unsee the structure of the trap once the lights have been turned on. These theories do not require belief to be dangerous. That is what makes them so terrifying. They do not require faith. like a religion or a cult. They simply require logic. They are mathematically sound, observationally supported and logically consistent. They are the inevitable results of 2 + 2 = 4. If you accept the premises of modern science, you must accept the monsters that come with them. If a madman on a street corner tells you the world is ending, you can walk away. You can dismiss him. You can laugh. But when the smartest minds in human history, people like Einstein, Hawking, Penrose and Bostrom, show you the equations that prove we are standing on a trapdoor, you cannot walk away. You're forced to confront the reality that our safety is an accident and our survival is not guaranteed. The 7 theories we're about to discuss are not campfire stories. They are not science fiction designed to sell movie tickets. They are the logical endpoints of our current understanding of reality. They represent the boundaries where human hope collides with cosmic indifference. Some of them suggest that we're alone in a graveyard. Some suggest we are being hunted by things we cannot see. Some suggest that we are already dead, and we just haven't noticed it yet. By clicking on this video, and by staying with me this far, you have made a choice. You have chosen to step out of the nursery. You have chosen to look behind the curtain of reality. I need you to understand that there is no going back after this. You cannot reclaim your ignorance. You cannot reclaim the comfort of the illusion. Once these ideas enter your mind, they will stay there. They will sit in the back of your subconscious when you look at the stars tonight. They will be there when you read the news about space exploration. They will be there when you lie in bed and wonder about the purpose of your life. This is the burden of knowledge. It is heavy, it is cold, and it is permanent. If you are not ready to carry that weight, I urge you to turn this off right now. Go back to the illusion. Go back to the safety of the daily grind. There is no shame in choosing happiness over truth. But if you are still here, if you are the kind of person who needs to know, even if it hurts, then let us begin. Let us dismantle the safety of your world, one equation at a time. Before we can fully comprehend the monsters hiding in the dark, we must first look down at our own hands. We must look at the ground beneath our feet. We must understand the object that is being hunted. It is easy to feel significant when you are standing in the middle of a crowded city, surrounded by concrete skyscrapers, high-speed data networks, and 8 billion other human beings. It is easy to feel that our existence is inevitable, that humanity is the main character of the cosmic story, and that the universe was built to house us. But the cold, hard mathematics of astrophysics tell a very different, very humbling, and very terrifying story. To say that we are lucky is an insult to the laws of probability. We are not lucky. We are statistical anomalies so extreme that, by all rights, we should not exist. We are a glitch in the thermodynamics of a dead universe. Consider the chain of events required to put you in this chair, listening to this voice, right now. It is a sequence of coincidences so precise that if you were to replicate the universe 1 trillion times, it might never happen again. First, consider our location. We live on a small wet rock that is orbiting a star at the exact microscopic distance where water remains liquid. This is the Goldilocks zone, or the habitable zone. But do not let that cute name fool you into thinking it is a wide, comfortable garden. It is a razor-thin tightrope. If Earth were just 5% closer to the Sun, our oceans would not just get warmer, they would boil. We would suffer a runaway greenhouse effect like our neighbour Venus, where the atmosphere is thick enough to crush a submarine, the rain is made of sulfuric acid, and the surface temperature is hot enough to melt lead. That is what lies just a few million miles to our left. Now, look to the right. If we were just 5% further away from the Sun, the planet would freeze. The carbon dioxide would turn to ice. The oceans would solidify into a global glacier miles deep. We would be a frozen dead wasteland like Mars. We are balancing on a knife's edge between fire and ice, surviving only because we happen to fall into this specific narrow orbit. But location is just the beginning of the miracle. We are protected by invisible forces that we barely understand and completely take for granted. Deep beneath your feet, thousands of miles down, there is a ball of liquid iron the size of Mars spinning in the centre of the Earth. This dynamo generates a magnetic field that stretches out into space, surrounding our planet in a protective bubble. You cannot see it, you cannot feel it, but without it, you would be dead in seconds. This magnetic field is the only thing standing between us and the Sun. The Sun is not a gentle light bulb. It is a raging thermonuclear fusion reactor. It constantly screams streams of high-energy particles and deadly radiation at us, known as the solar wind. Without our magnetic shield, this solar wind would strip away our atmosphere. It would blow the air we breathe into deep space. It would scour the surface with radiation, sterilizing the soil and breaking apart the DNA of every living thing. Mars once had an atmosphere. Mars once had water. But its core cooled, its magnetic shield died, and the sun stripped it naked, leaving it a dead, red corpse. We are alive only because the iron heart of our planet is still beating. Then, look further out. We are guarded by a giant. The planet Jupiter does not just sit there looking pretty in a telescope. It acts as a massive gravitational vacuum cleaner. Its gravity is so immense that it pulls in the asteroids, comets, and meteors that wander through our solar system. For billions of years, Jupiter has taken the hits for us. It has swallowed the world killers that would otherwise have bombarded Earth into dust. Without Jupiter sweeping the solar system clear, complex life on Earth would be impossible because we would be hit by an extinction-level asteroid every few thousand years. We are living in a shooting gallery, and we are surviving only because we have a bodyguard standing in front of us. And finally, consider the dimension of time. The universe is hostile to life, and Earth itself has tried to kill us more times than we can count. For 3.8 billion years, life on this planet has fought a desperate, bloody war against extinction. We have survived 5 major mass extinctions, events that wiped out up to 90% of all species on the planet. We have survived ice ages that froze the world from the poles to the equator. We have survived supervolcanoes that choked the sky with ash for centuries, blocking out the sun and starving the food chain. Think about your own lineage. Every single one of your ancestors, going back to the first single-celled organism in the primordial sludge, managed to survive long enough to reproduce. Not a single one of them was eaten before they passed on their genes. Not a single one froze to death, or starved, or died of plague, or broke a bone and was left behind before they could create the next generation. You represent an unbroken chain of survival stretching back through eons of violence, death, and struggle. You are the tip of a spear that has been thrust through 4 billion years of nightmares. This realization should make you feel special. It should make you feel precious. It should make you realize that human life is a diamond in a sea of broken glass. But in the context of the theories we're about to discuss, this rarity does something else. It makes you feel exposed. Because if life is this rare, if consciousness is this fragile, if a planet like Earth is a 1 in a trillion miracle, then we are the only light in a very, very dark room. We are a beacon shining in the middle of a black ocean. And when you are the only light in a dark room, you do not just attract wonder, you attract attention. We have spent the last 100 years shouting into the void. We have sent radio signals, television broadcasts, and space probes carrying golden records with maps to our home. We have been like a lost child in a dark forest, lighting a fire and screaming for help, assuming that anyone who hears us will come to save us. We assume that civilization implies morality. We assume that if an alien species is advanced enough to travel the stars, they must be kind enough to say hello. But what if we are wrong? What if the reason the universe is so quiet is not because there is no one out there? What if the silence is not an absence of life, but a strategy? This brings us to the first, and perhaps the most famous, of our terrifying theories. It is a solution to the Fermi Paradox that turns our curiosity into a death sentence. It suggests that the universe is not an empty ocean waiting to be explored, but a hunting ground waiting for a victim. It suggests that the smartest thing a civilization can do is keep its mouth shut. And we have already said too much. To understand the first theory, we have to look at the numbers, and the numbers are not just large, they are aggressive. They scream at us. They demand an explanation. Our galaxy, the Milky Way, is a spiral disk of unimaginable proportion. It contains between 100 and 400 billion stars. That is a number so vast that the human brain cannot truly comprehend it. If you were to count every single grain of sand on every single beach on planet Earth, every grain in the Sahara, every grain in the Gobi, every grain on the coastlines of the Americas, you would roughly match the number of stars in just our local neighbourhood. And thanks to the Kepler Space Telescope and our modern understanding of exoplanets, we now know that planets are not rare, they are the rule. Almost every star you see in the night sky is a sun to a solar system. Billions of those planets are rocky, Earth-sized, and sitting in the habitable zone where water can flow and chemistry can become biology. Even if life is incredibly rare, the sheer volume of the dice roll suggests that we should be drowning in company. But the sheer volume of real estate is not the scary part. The scary part is the time. The universe is approximately 13.8 billion years old. The Earth is only 4.8 billion years old. This is a discrepancy that should send a chill down your spine. It means that there are stars and planets out there that are billions of years older than our Sun. It means there were potential habitats for life existing in the galaxy for eons before the Earth even formed from the dust. Imagine a civilization that started just 1 billion years before humanity. Think about that time frame. 1 billion years. Now think about how far humanity has come in just the last 10,000 years of recorded history. We went from banging rocks together in caves to splitting the atom, mapping the human genome, and landing robots on Mars. That is what we achieved in 10,000 years. Now, give that alien civilization a head start of 1 billion years. To them, we would not even be ants. We would be bacteria. We would be less than dust. Their technology would be indistinguishable from magic, and their engineering would be indistinguishable from the laws of physics. Mathematically, a civilization this advanced should not just be visible, they should be everywhere. In the 1940s, the mathematician John von Neumann proposed the concept of self-replicating spacecraft. This is the ultimate tool for galactic colonization, and it does not require faster-than-light travel. It just requires patience and exponential math. The idea is simple. You launch a single probe to a nearby star system. It travels slowly, maybe at just 10% of the speed of light. It takes decades or centuries to arrive, but when it lands on an asteroid or a moon, it wakes up. It mines raw materials from the rock, it builds a factory, and then it uses that factory to build 2 copies of itself. Once those 2 copies are built, they fuel up and launch to 2 more stars. When they arrive, they build 2 more factories and create 4 probes, then 8, then 16, then 32. This is the power of exponential growth. It starts slow, but it explodes with terrifying speed. Even if these ships travel at a slow, lumbering crawl across the void, and even if they take 1,000 years to replicate at each stop, the math says they would colonize the entire Milky Way galaxy, every single star system, in less than 500,000 years. 500,000 years is nothing. It is a blink of an eye in cosmic time. It is a rounding error in the age of the universe. The dinosaurs ruled the Earth for 160 million years. A civilization could have colonized the galaxy 300 times over, while the T-Rex was walking around. This means that if even one civilization in the entire 13 billion year history of the galaxy had the ambition to expand, they should have done it by now. They should be here. Their probes should be mining our asteroid belt. Their megastructures should be blocking the light of distant stars. Their radio signals should be as loud as the sun. The galaxy should be a crowded, noisy, bustling metropolis of commerce and chatter. It should be a banquet hall filled with guests, with music playing and lights blazing in every window. But when we look up, we see nothing. We point our most sensitive radio telescopes at the sky, dishes the size of football fields, expecting a symphony of data, and we hear only static. We listen to the background hum of the universe, hoping for a pattern, a sequence of prime numbers, a hello, but we hear only the random noise of dying stars and cosmic radiation. We scan the stars for Dyson spheres, massive shells harvesting the energy of suns, and we see only cold, dead wilderness. We analyse the atmospheres of exoplanets for industrial pollutants or artificial light, and we find only silence. This is the great silence. This is the Fermi Paradox. And usually, when scientists discuss this, they treat it like a fun intellectual puzzle. They say things like, maybe they are shy, or maybe they are meditating in virtual reality, or maybe they are protecting us like a nature preserve. We invent comforting stories to explain the empty room. But there is a darker interpretation, a much more visceral explanation for why the banquet hall is empty. Imagine you walk into a stranger's house. The lights are on. The food is still hot on the table. The television is playing, but there is no one there. You do not assume they are playing hide and seek. You do not assume they are shy. You assume something terrible has happened. The silence is not peaceful. It is suspicious. It implies that there is a variable in the equation that we are missing, a variable that prevents civilizations from surviving or prevents them from speaking. If the math says they should be here, and our eyes say they are not, then one of two things is true. Either we are the first and only life in the universe, which seems arrogantly unlikely given the numbers, or everyone else is hiding. And if they are hiding, we need to ask ourselves a very specific question. What are they hiding from? What kind of predator is so efficient, so omnipresent, and so terrifying that it forces a billion-year-old super civilization to turn off its lights and hold its breath? We are about to find out. And it turns out the universe is not a metropolis. It is a forest. And it is very, very dark. The answer to the great silence might not be found in the equations of a physicist, but in the nightmares of a science fiction writer. In 2008, the Chinese author Liu Cixin published a book titled The Dark Forest, and within its pages he laid out a theory of cosmic sociology so cold, so logical, and so terrifying that it has kept astronomers awake ever since. He proposes that our naive optimism about finding alien friends is based on a fundamental misunderstanding of the rules of the game. We assume the universe is a community. Liu Cixin argues that the universe is a war zone, and the silence we hear is not peace. It is the held breath of a sniper. To understand the dark forest, we must first accept two unshakable axioms of cosmic sociology. These are the rules that govern life among the stars, and they are as immutable as gravity. Axiom number 1. Survival is the primary need of civilization. This seems obvious, but its implications are absolute. A civilization will do anything, sacrifice anything, and destroy anything to ensure its own existence. It is the biological imperative written into the DNA of every living thing. If pushed to a choice between its own survival and the survival of another, it will choose itself every single time. There is no morality in extinction. There is only the binary state of being alive or being dead. Axiom number 2. Civilizations continuously grow and expand, but the total matter in the universe remains constant. This is the economic engine of the conflict. A civilization that survives will eventually master its home planet, then it will master its star system, then it will need more. It will need more energy, more minerals, more living space. But the universe is finite. There are only so many stars. There are only so many resources. This means that the universe is a zero-sum game. Every star system occupied by another civilization is a star system that you cannot use. Every resource they consume is a resource denied to your descendants. We are all fighting over the same pie, and the pie is not getting any bigger, but the eaters are multiplying exponentially. Now you might argue that advanced civilizations would be benevolent. You might think they would have evolved past the primitive need for war. You might think they would be wise, peaceful, and eager to trade. And perhaps you're right. Perhaps 99% of civilizations are pacifists. But in the dark forest, benevolence is irrelevant because of a concept called the chain of suspicion. Imagine you're a civilization and you discover another civilization across the galaxy. You are peaceful. You have no intention of attacking them, but you have a problem. You cannot know what they are thinking. You are separated by hundreds of light years. Light takes centuries to travel between you. You cannot have a conversation. You cannot look them in the eye. You cannot assess their culture. So you have to guess. You ask yourself, are they benevolent or malicious? You don't know, but let's assume you guess they are benevolent. That leads to the next question. Do they think we are benevolent? You can't know that either. Even if they are peaceful, they might look at us, a young, aggressive species, and decide we are a threat. They might attack us out of fear, and then you have to go a level deeper. You have to ask, do they know that they might be afraid of us? It becomes an infinite loop of paranoia. I think that I think that they are dangerous. In this chain of suspicion, trust is mathematically impossible. The distances are too vast. The cultural differences are too deep. You can never be 100% sure that the other guy won't pull the trigger. And in a universe where weapons can destroy entire stars, maybe is not good enough. You cannot risk the lives of your entire species on a maybe. If there is even a 1% chance that they are hostile, the only logical, rational move, the only move that guarantees your survival, is to shoot first. You don't attack them because you hate them. You don't attack them because you are evil. You attack them because if you wait for them to attack you, it will be too late. The mathematics of survival forces every civilization into a corner. where preemptive genocide is the only safe option. This leads us to the metaphor that gives the theory its name. Liu Cixin describes the universe as a dark forest. Imagine a dark, dense forest at night. It is terrifyingly quiet, but it is not empty. The forest is full of armed hunters. Every single civilization is a hunter stalking through the trees. They are pushing aside the branches with extreme care. They are trying not to make a sound. They are stepping over dried leaves so they don't crunch. They are controlling their breathing. The hunter does not light a fire, because a fire would give away his position. He does not shout into the darkness, because shouting would reveal his location. He knows that the forest is teeming with other hunters, ghosts in the trees, all doing the exact same thing. They are all hiding. They are all listening. And if the hunter spots another life form, another hunter, an angel, a demon, a crying baby, it doesn't matter. He doesn't pause to say hello. He doesn't check if it is friendly. He instinctively raises his rifle and fires. In this forest, hell is other people, an eternal threat that any life that exposes its own existence will be swiftly wiped out. This is the picture of cosmic sociology. The universe is a grand battlefield where everyone is hiding and everyone is armed. This explains the Fermi Paradox perfectly. The reason we don't hear anyone is not because they aren't there. It is because they are smart. They are keeping their heads down. They know the rules. They know that in the dark forest, silence is armor. To broadcast your coordinates, to send out radio waves, to invite others to visit, is not an act of exploration. It is an act of suicide. It is walking into the middle of the battlefield, lighting a flare and screaming, "I am here, I am here." The silence of the night sky is the silence of a graveyard where everyone is terrified to make a sound. The civilizations that were loud, the ones that were naive, the ones that wanted to make friends, they are already dead. They were the easy targets. They were spotted by the older, colder, more paranoid hunters, and they were eliminated before they even knew the war had started. The only ones left are the quiet ones, the ones who learned to hide, and us. We are the new kid in the forest. We are the toddler wandering through the brush, singing a song at the top of our lungs, completely unaware that 1,000 rifles are slowly turning in our direction, locking onto the sound of our voice. We think we are alone because it is quiet, but the quiet is the only thing keeping us alive, and we are doing everything in our power to break it. In the dark forest, there is no such thing as a warning shot. There is no diplomacy. There is no declaration of war. There is only the strike. If a hunter sees a shaking branch or spots a flicker of light in the distance, he does not pause to ask questions. He does not wonder if the entity behind the bush is a saint or a sinner. He does not calculate the moral weight of his actions. He knows that if he hesitates for even a second, if he allows curiosity to delay his trigger finger, he might be the one who dies. The mathematics of cosmic survival are brutal in their simplicity. It is infinitely cheaper to destroy a civilization than to talk to one. To investigate a star system requires a fleet of ships, vast resources, biological risk, and centuries of travel. To destroy a star system simply requires a small projectile, a photoid, accelerated to near light speed and aimed at the host star. It is a low-cost, high-reward move. It eliminates a potential threat before it can ever become a rival. And because the universe is so vast, and the weapon moves so fast, the victim never even sees the face of their executioner. Let us visualize exactly what this end looks like. Let us slow down the clock and witness the death of a solar system that made the mistake of broadcasting its location. It begins not with an invasion fleet darkening the skies, but with a single point of light moving through the outer reaches of the system. It is a small object, perhaps no larger than a shipping container, but it is travelling at 99.9% of the speed of light. It carries no warhead. It needs no explosives. The kinetic energy alone, derived from its relativistic mass, is greater than all the nuclear weapons ever built by humanity combined. It slips past the gas giants in silence. It pierces the orbital plane of the habitable planets in a fraction of a second. It is moving too fast to be tracked by radar. It is moving too fast for the civilization to even realize it is under attack. The target is not the inhabited planet. The target is the sun. The projectile strikes the stars. Photosphere. It punches through the outer layers of plasma like a bullet hitting water. It dives deep into the convection zone, tunneling towards the core. The the impact is catastrophic. The delicate hydrostatic equilibrium, the balance between the crushing inward weight of gravity and the outward push of nuclear fusion is instantly shattered. The star essentially hiccups. A shockwave of impossible violence ripples outward from the impact point, tearing the solar atmosphere apart. For the civilization living on the third planet, the sky suddenly changes. The sun, which has been a yellow-white constant for billions of years, suddenly brightens. It turns a blinding, violent blue. The radiation output spikes by a factor of 1,000. In the cities on the day side of the planet, the atmosphere instantly ignites. The air itself turns into plasma. Oceans do not just boil, they flash vaporize into superheated steam in a single heartbeat, scouring the continents down to the bedrock. Buildings, forests and mountains are stripped away like dust in a hurricane. There is no time to scream. There is no time to say goodbye. The biological matter of billions of living beings is reduced to its constituent atoms before the neural signals of pain can even reach their brains. On the night side of the planet, the moon suddenly glows as bright as the sun, reflecting the death throes of the star, before the shockwave of the solar explosion wraps around the curvature of the world. The planet is stripped of its atmosphere, then its crust, and finally, it is swallowed whole by the expanding fireball of the dying sun. In the span of a few hours, a civilization that may have existed for 1,000,000 years, a culture with art, history, love, mathematics, and dreams, is erased. It is not conquered, it is deleted. The star expands into a red giant, then collapses, leaving behind nothing but a glowing nebula of dust and gas. The coordinates have been cleansed. The threat has been neutralized. And the hunter who fired the shot is already light years away, scanning the dark for the next flicker of movement. This leads us to the most uncomfortable realization about our own behavior. For the last 100 years, humanity has been acting with suicidal naivety. We have been blasting high-power radio waves into the cosmos. We have sent maps of our location on the Voyager probes, etched with diagrams of our DNA and the exact position of our sun relative to nearby pulsars. We have sent messages to globular clusters inviting a response. We act like a toddler who has wandered into a jungle at night. We are crying out, assuming that anyone who hears us will be a mother figure coming to comfort us. We assume that intelligence leads to benevolence. But in nature, intelligence is just a tool for hunting. When a baby cries in a forest, it might attract its mother, yes. But it is far more likely to attract a wolf. The wolf does not hate the baby. The wolf is not evil in the way we understand the word. The wolf is simply hungry, or it is protecting its territory, or it is removing a future competitor. The motivation is irrelevant. The outcome is the same. By broadcasting our existence, we have painted a target on our backs. We have turned on a flashlight in a dark room full of snipers. We have violated the first rule of the dark forest. Keep quiet, keep your head down, and never ever let them know where you are. So when you look at the Fermi Paradox, when you look at the Great Silence, do not ask where is everyone. Ask who survived. The universe has been around for 13 billion years. It is highly probable that millions of civilizations have risen before us. Some were paranoid, and some were loud. The loud ones, the ones who broadcast their art and their coordinates, the ones who sought connection, were the first to be targeted. They were the easy kills. They were wiped out eons ago. Their stars turned into nebulas and their planets turned into dust. The great silence we hear is not an empty room. It is a library where everyone is afraid to speak. It is a graveyard of the noisy. The civilizations that survive are the ones that learn to shut up. They are the ones hiding in the dark, shielding their radio leakage, masking their heat signatures, and listening intently to the void. And right now, on this tiny blue rock, we are the only ones foolish enough to be screaming. We are announcing our position to a galaxy that learned to be quiet a long time ago, and sooner or later, something is going to hear us. And when they do, they won't send a message. They will send a photoid. If the dark forest is a threat from the outside, a danger lurking in the black spaces between the stars, our next theory brings the horror much closer to home. It is a threat from the inside. It is a betrayal by the very laws of physics that hold your body together. It is a theory that suggests that the foundation of our reality is not solid rock, but a trapdoor waiting to open. To understand this nightmare, you have to understand the fundamental concept of stability. In the world of physics, stability is everything. It is the goal of every object and every field in the cosmos. Everything seeks the lowest possible energy state. It is the path of least resistance. It is the universal rule of relaxation. Think of a ball sitting at the very top of a steep, jagged hill. It has a lot of potential energy. It is unstable. If you nudge it, it will roll. It will bounce and crash all the way down until it reaches the bottom of the valley. Once it settles in the deepest part of the valley, it stops. It has nowhere else to go. It has lost all its excess energy. It is now stable. It is safe. It will stay there for eternity unless something massive comes along and physically picks it up. We call this state of absolute, unshakable stability a true vacuum. It is the bedrock of reality. It is the ground floor of the universe. For decades, physicists and cosmologists believed that our universe was in this state. We looked around at the stars, the atoms, and the forces of nature, and we assumed that they had all finished rolling down the hill billions of years ago, shortly after the Big Bang. We believed that the fundamental fields governing our existence had settled into their final, permanent configuration. We thought we were sitting comfortably at the bottom of the valley, on solid ground, safe from any further changes. Specifically, we're talking about the Higgs field. You may have heard of the Higgs boson, the so-called God particle. But the particle is just a ripple. The real player is the field itself. You can think of the Higgs field as an invisible, ghost-like ocean of energy that permeates every single inch of the cosmos. It is everywhere. It is inside your body. It is inside the empty space between the stars. You're swimming in it right now, even if you cannot feel it. This field has a critical job. As particles move through this invisible ocean, they interact with it. They push against it, and it pushes back. This interaction, this resistance, is what gives particles their mass. It is what makes an electron heavy enough to orbit a proton. It is what allows atoms to form. It is the reason stars can burn and biology can exist. Without the Higgs field, every particle in your body would be massless. You would instantly dissolve, and your constituent parts would fly apart at the speed of light. The value, or the strength, of the Higgs field determines the mass of every object in the universe, and therefore, it determines the laws of chemistry and physics as we know them. The universe is built on top of the Higgs field, like a house built on a foundation. We always assumed that the Higgs field was at the bottom of the valley. We assumed it was at its lowest possible energy state, and therefore it was stable. We thought the foundation was concrete. But in 2012, everything changed. When we finally discovered the Higgs boson particle at the Large Hadron Collider in Switzerland, we were able to measure its mass for the first time. We finally got a look at the blueprint of the foundation, and the numbers terrified the theoretical physicists. The data suggests that the Higgs field is not at the bottom of the valley. The math indicates that the ball did not finish rolling. Instead, it appears to be stuck on a little ledge, a shallow depression in the side of the cliff halfway down. This is what we call a false vacuum. It means that our universe is not stable. It is what physicists call metastable. Metastability is a terrifying concept. It is the stability of a house of cards. It is the stability of a landmine that hasn't been stepped on yet. We are not standing on solid ground. We are balancing on a thin sheet of ice over a deep, dark abyss. The ball has not finished the journey. It is just caught on a snag. It is resting on a fragile shelf of rock, and the terrifying implication of potential energy is that the ball always wants to finish the journey. The universe wants to be in the true vacuum. It craves that lower energy state. It is pushing against the floor of our reality, trying to break through, and directly below the ledge we are living on, directly below the fabric of the universe as we know it, there is a sheer drop, a drop into a state of physics that we cannot even comprehend. If the Higgs field were to slip off this ledge, if it were to slide down to the true bottom of the valley, the laws of physics would change instantly. The values of mass would be rewritten. The chemistry of the universe would be deleted. We are building a civilization on the edge of a volcano, and we have only just realized that the ground beneath our feet is trembling. We thought the universe was a finished product, a solid stage for our drama, but it turns out the concrete is still wet, the floor is rot, and gravity is pulling everything down into the dark basement that lies beneath existence itself. In the comfortable, predictable world of classical physics, The physics of Isaac Newton, falling apples and rolling balls, being stuck on a ledge is actually a relatively safe place to be. To roll down the hill, the ball would first have to roll up. It would need to gain energy to climb over the little barrier, the rim of the cup, that separates the false vacuum from the true vacuum. Since the universe tends to lose energy, not gain it spontaneously, the ball should sit there forever. We should be secure in our metastability, protected by the walls of the valley. We should be able to sleep soundly, knowing that the energy barrier is too high to climb, and that the foundation of our reality, while not perfect, is at least secure. But here is the problem that keeps the theorists awake at night. The universe is not classical. It is quantum. And in the quantum realm, the laws of reality soften. The rules that govern your daily life, rules like solid objects cannot pass through other solid objects, do not apply. In the subatomic world, the word impossible does not exist. It is replaced by the word improbable. According to the strange, hazy laws of quantum mechanics, particles do not have fixed positions like marbles on a table. They are not solid dots. They are waves of probability. A particle is not just here, it is mostly here, but it is also a tiny bit over there, and a tiny bit everywhere else. This leads to a phenomenon known as quantum tunneling. It sounds like science fiction or a glitch in a video game, but it is a proven, fundamental fact of life. It is the reason the sun shines. Protons must tunnel through their electrostatic repulsion to fuse and create light. It is the reason your computer's transistors work. In the quantum world, if a particle hits a wall enough times, eventually it won't bounce off. It won't lose energy. It will simply borrow energy from the vacuum, cheat the laws of motion, and pass right through the solid barrier as if it weren't there. It teleports from one side of the mountain to the other without ever climbing the peak. Now, apply this mechanism to the stability of the universe itself. It changes the picture entirely. It implies that the barrier protecting us from the true vacuum, the wall of the ledge we're standing on, is not a solid wall. It is a screen door. It is a ghost. And every second of every day, every cubic centimetre of space in the cosmos is rolling the dice. The Higgs field is constantly fluctuating. It is vibrating. And every vibration is a test of the barrier. All it takes is one single point, one tiny microscopic fluctuation in the fabric of space-time. We are not talking about a massive event like a supernova. We are not talking about a collision of galaxies. We are talking about a subatomic accident. It could happen in the crushing gravity of a distant black hole. It could happen in the empty, cold void between galaxies where there is nothing but dust. Or, most terrifyingly, it could happen in the empty space between your eyes and this screen. A single point in the Higgs field could spontaneously tunnel through the barrier and drop to the lower energy state. When this happens, it creates what physicists call a nucleation bubble. You can visualize this by thinking about a bottle of supercooled water. You can put a bottle of pure water in the freezer and chill it well below freezing, but if it is perfectly still, it stays liquid. It is metastable. It wants to be ice, but it hasn't figured out how to start yet. But if you tap the bottle, just a tiny, gentle tap, that single point of disturbance instantly turns to ice, and that ice spreads. It shoots through the bottle, transforming the liquid into solid in a blink. That is exactly what would happen to the universe. The moment that tiny point in space drops to the true vacuum, it releases a massive amount of potential energy. The difference in energy between the false vacuum, where we live, and the true vacuum, the basement, is vast. This energy has nowhere to go, so it pushes outward. It expands. And because the difference in energy is so catastrophic, the force behind this expansion is infinite. This is not an explosion in space. This is an explosion of space. A bubble of new reality has formed, and it is hungry. Inside that bubble, the Higgs field has settled to the bottom. The laws of physics inside the bubble are different. They are the laws of the true vacuum. But on the edge of the bubble, the wall is fueled by the energy of the collapse. It becomes a runaway reaction. The true horror of this theory is the randomness. There is no countdown. There is no trigger we can avoid. We don't have to build a machine to cause it. We don't have to make a mistake. It is a lottery that is being played by every atom in the universe, continuously, forever. We are winning the lottery every single fraction of a second that we continue to exist. But we only have to lose once. The universe doesn't need a reason to destroy us. It just needs a statistical fluke, a roll of the dice that comes up snake eyes. And in a universe this big, with this much time, even the most improbable events eventually become inevitable. The tunnel is open, the ball is shaking, and we are just waiting for it to fall. The scary part isn't that it might happen. The scary part is that, statistically speaking, in an infinite universe, it has likely already happened somewhere. The bubble might already be on its way. We're simply waiting for the wall to hit us. Once the nucleation bubble forms, the laws of thermodynamics take over with ruthless mathematical efficiency. Because the interior of the bubble is at a lower energy state than the exterior, the wall of the bubble is pushed outward by a tremendous irresistible pressure. It accelerates instantly. It does not ramp up like a car engine. It does not gain momentum slowly like a tsunami. In a fraction of a nanosecond, the wall of the bubble reaches the cosmic speed limit. It hits the speed of light, and this specific speed, 297,792,458 meters per second, is the reason why this theory is the ultimate existential horror. It is the reason why this is the perfect killer. In our universe, information travels at the speed of a light. This is a fundamental law of causality. When you look at a star, you're not seeing the star as it is now. You're seeing the light that left the star years ago. You're looking into the past. The light from the sun takes 8 minutes and 20 seconds to reach your eyes. If the sun were to explode right now, you would not know it. You would continue to walk your dog, or sit at your desk, or laugh at a joke, bathing in the warm yellow light of a ghost. For 8 minutes and 20 seconds, you would be living in a reality that no longer exists. But in the case of a vacuum decay, the death wave is moving at the limit of information itself. The bubble expands at the exact same speed as the light that would warn you of its approach. This creates a terrifying blind spot. It means that you can never, ever see it coming. There is no warning siren. There is no ominous glow in the night sky. There is no change in the readings of our telescopes. There is no gravitational tremor that arrives before the quake. You could be looking directly at the point of origin through a high-powered observatory. You could be staring right at the spot where the bubble began, and you would see nothing but empty space or distant twinkling stars. The bubble is crashing through galaxies, deleting solar systems and erasing civilizations, and the light from those dying stars is being swallowed by the leading edge of the bubble before it can escape to tell the tale. The wall of the vacuum acts like an event horizon. Nothing informationally escapes it. If a vacuum decay event began 1 billion years ago in the Andromeda Galaxy, it is currently tearing through the void toward us, devouring millions of stars, and we are completely blind to it. To our eyes, Andromeda looks peaceful and beautiful. We take pictures of it. We admire its spiral structure, but that image is a lie. In reality, it might already be gone. The bubble could be a light year away. It could be an inch away. It could be passing the orbit of Pluto right now. And when it hits, the experience is not painful. It is not violent in the way a bomb is violent. It is simply a cessation. To understand why, you have to understand the speed of your own biology. The human machine is slow. It takes time for your eyes to convert photons into electrical signals. It takes time for those signals to travel down your optic nerve to the back of your brain. It takes time for your visual cortex to process the data and construct an image of reality. And it takes even more time for your amygdala to register fear, or for your pain receptors to send a signal from your skin to your spine. Nerve impulses travel at roughly 100 meters per second. The vacuum bubble travels at 300,000 meters per second. The wall moves 3 million times faster than your ability to feel it. One moment, you're sitting there. Your neurons are firing. Your heart is beating. Your atoms are vibrating in the false vacuum. The next moment, the wall passes through you. It takes less time for the wall to cross the width of your brain than it takes for a single photon to cross a single atom. You would literally be dead before your brain could process the fact that you were dying. You would not feel heat. You would not hear a sound. You would not see a flash. You would simply cease to be a continuous stream of consciousness. One frame of the movie, you are there. The next frame, the film has been burned. Inside the bubble, the reality you knew is gone. The laws of physics have been rewritten. The Higgs field has dropped to its new lower value. Suddenly the mass of the electron changes. The strength of the electromagnetic force shifts. The delicate, precise balance that allows protons and neutrons to bind together is shattered. Chemistry, as we know it, becomes impossible. The very concept of an atom becomes obsolete. The electrons that orbit the nuclei of your cells simply fly away or collapse. The bonds that hold your DNA together snap. The molecules that make up the Earth, the Sun, and the atmosphere simply fall apart or collapse into new, unrecognizable states of matter. The universe continues, of course, energy is conserved, but it is a universe of strange, cold, alien physics where nothing like us can ever exist again. It is a universe where stars cannot shine, where water cannot flow, and where life cannot think. It is the cosmic format button, a total, perfect, and instant deletion of history. All the art we have created, all the wars we have fought, all the memories we have stored, every digital record, every stone monument, every fossil in the ground, it is all wiped clean. It is not just that we die, it is that the record of our existence is erased. In a normal disaster, like an asteroid or a nuclear war, there are ruins, there are ashes. There is evidence that something was here. But in a vacuum decay, the canvas itself is burned. There is no evidence. There is no history. There is only the expanding sphere of the new vacuum, growing forever outward at the speed of light, leaving behind a blank, silent slate that will never know we were here. We are ghosts waiting for an exorcism that might have started 1 billion years ago, and we are smiling at the sky, completely unaware that the call has already been made. To understand why the sky is quiet, we must first understand why the Earth is loud. We look around at our planet, at the green forests, the teeming oceans, the sprawling cities, and the 8 billion people arguing on the internet, and we fall into a cognitive trap. We assume that life is a natural, inevitable consequence of the universe. We assume that if you give a planet water and sunlight, biology is the automatic result. We assume that if you give life enough time, intelligence is the automatic result. But this is survivor bias. We are the winners of a lottery who have convinced ourselves that everyone wins the lottery. We look at our own success and assume it is the standard, when in reality it might be the exception to a rule so harsh that it has sterilized the cosmos. The Great Filter theory suggests the exact opposite of our optimism. It proposes that the path from dead matter to a star-travelling species is not a smooth, gentle ramp that anyone can walk up. It is a ladder, and the rungs of this ladder are widely spaced, slippery, and covered in razor wire. Worst of all, at certain intervals on the ladder, there are filters. These are evolutionary bottlenecks, impossible hurdles, or probability traps that stop life dead in its tracks. The theory dictates that there is at least one step in the process of evolution that is so unlikely, so difficult, and so dangerous that almost no one makes it past. Consider the sheer, staggering improbability of the very first step, abiogenesis, the transition from dead chemistry to living biology. For life to begin, complex non-living molecules have to spontaneously organize themselves into a structure that can replicate itself. This is not just mixing chemicals in a beaker and heating them up. This is the equivalent of a tornado sweeping through a junkyard and accidentally assembling a fully functional Boeing 747, complete with fuel and a pilot, out of the scrap metal. We still do not know how it happened. We have tried to replicate it in our most advanced laboratories for decades. We have simulated the primordial soup, we have blasted it with electricity, we have subjected it to extreme pressure, and yet we have never created life from scratch. It is entirely possible that this event is so vanishingly rare that it has only happened once in the entire history of the observable universe. It is possible that the universe is full of oceans, full of amino acids, and full of sunlight, but they just sit there, sterile and dead, for eternity, because the spark never strikes. We might be the only sludge that ever woke up, but even if simple life is common, the ladder keeps going, and the next rung is even higher. For 2 billion years, half the lifespan of our planet, life on Earth was nothing but simple, single-celled slime, bacteria, prokaryotes. They floated in the oceans, doing absolutely nothing but dividing and existing. They did not build structures. They did not evolve into complex animals. They were stuck. Evolution had hit a wall. There was no upward momentum. The Earth was a slimy green ball of boredom. It took a freak accident, a biological miracle, to break through this barrier. This is the step known as eukaryogenesis. It happened when one bacteria tried to eat another bacteria, but instead of digesting it, they formed a symbiotic relationship. The internal bacteria became the mitochondria, the powerhouse of the cell. This gave life the energy budget to become complex. It allowed cells to get bigger, to specialize, to build DNA that was protected inside a nucleus. The genetic evidence suggests that this event, the birth of the eukaryotic cell, happened exactly once. In 4 billion years of planetary history, with oceans full of trillions of organisms interacting every millisecond, it happened once. That suggests that complex life is not a rule. It is a statistical error. It suggests that if you rewind the tape of history and play it again, you would likely just get 4 billion years of slime, and then the sun would explode, and the ladder goes on. Multicellularity. The ability for cells to stop acting as individuals and start acting as a collective body. This requires a level of biological cooperation that is counterintuitive to the selfish nature of survival. Then sexual reproduction, which allows for genetic diversity. Then the development of a central nervous system, the development of a brain, the development of tool use. Each of these is a filter. Each of these is a point where life could have, and probably should have, stalled out. Think about the dinosaurs. They were the masters of this planet. They ruled the Earth for 160 million years. They were perfectly adapted predators. They were successful, and yet, in all that vast stretch of time, across millions of generations, they never built a telescope. They never wrote a book. They never looked at the moon and tried to calculate its orbit. Evolution does not want intelligence. Evolution wants survival. Big brains are expensive. They consume 20% of our energy while making up only 2% of our body mass. From an evolutionary standpoint, high intelligence is a liability, not an asset. It is a waste of calories unless it pays off immediately. The dinosaurs prove that you can dominate a planet for eons without ever developing the capacity to leave it. So when we look at the silence of the universe, we have to ask ourselves a terrifying question. Where is the great filter? Where is the wall that stops life? Is it the step we've already taken? Are we the chosen ones who survived the impossible odds of abiogenesis and the eukaryotic merger? Is the reason we are alone simply because we are the first to climb this high? Or is the filter not in our past but in our future? Is the reason we don't see anyone else because the hardest step is the one we're about to take? The great filter suggests that there is a trap somewhere in the timeline of life that catches almost everyone. And if we haven't hit it yet, then we are not the survivors. We are just the walking dead, marching happily down a hallway that leads to a slaughterhouse, completely unaware that the silence around us is the sound of a billion other civilizations hitting the wall that is waiting for us tomorrow. The location of the Great Filter is the single most important variable in the future of the human race. It is a binary question with only two possible answers, and the difference between them is the difference between godhood and extinction. It is the ultimate cosmic coin flip. One side of the coin represents infinite potential and a destiny among the stars. The other side represents a dead end, a closed loop, and a grave. To understand our place in the universe, we have to determine where this invisible wall is located on the timeline of history. Possibility number one is that the Great Filter is behind us. This is the optimistic view, the rare Earth hypothesis. It suggests that the hardest part of the journey is already over. It proposes that the step from dead matter to living cell, or the step from single-celled slime to complex animal, or the step from animal to sentient mind, is so impossibly difficult that it serves as a universal barrier. If this is true, then we are the winners of a galactic lottery. We are the statistical anomalies who managed to slip through the net that caught everyone else. If the filter is behind us, it means that the universe is indeed a graveyard of failed chemistry. It is full of planets that never developed life, or planets where life started but never got past the bacterial stage. It means that we are unique. It means that the silence of the night sky is not a threat, but a blank canvas. It implies that we are the first ancient civilization. We are the elder race that science fiction always talks about. The galaxy is an open road stretching out before us, empty and waiting to be claimed. We have already passed the test that everyone else failed. We have survived the bottleneck. The danger is in the rearview mirror, and the future is ours to write. This scenario brings with it a crushing sense of loneliness, but also a profound sense of responsibility. If we are the only conscious observers in the Milky Way, then we are the universe's only way of knowing itself. If we destroy ourselves, the universe goes blind. The lights go out. There will be no one left to marvel at the stars, no one to understand the laws of physics, no one to feel love or fear. We are the custodians of consciousness in a galaxy of dead rock. But then there is possibility number 2, and this is the thought that haunts the waking hours of futurists, philosophers, and astrobiologists alike. What if the filter is ahead of us? If the filter is ahead, it changes the entire narrative of human history. It means that life is not rare. It means that the universe is teeming with slime and fish and dinosaurs. It means that evolving intelligence is not a miracle, but a natural common process. It implies that thousands, perhaps millions of civilizations have reached the exact stage we are at right now. They built tools, they mastered fire, they built cities, they discovered electricity, they split the atom, they invented the computer, they looked up at the stars and dreamed of colonization. And then, they died. If the filter is ahead, it suggests that there is a trap waiting further down the timeline, a trap that is so deadly, so unavoidable, and so universal that it catches everyone. It suggests that there is a specific level of technological advancement where civilization inevitably destroys itself. It is a ceiling that no one can break through. Think about where we are right now as a species. We are standing at a very specific point in our development. We have discovered nuclear weapons, but we have not yet colonized other planets to ensure our species against a single, planet-wide disaster. We have created the internet and global communication, but we have also created misinformation algorithms that tear our societies apart. We are on the verge of creating artificial general intelligence, a mind that could be smarter than us, but we have no idea how to control it. We are altering our climate, but we lack the political will to stop it. The filter ahead theory posits that these are not just growing pains. These are the symptoms of the disease that kills civilizations. It suggests that technology itself is the weapon. Perhaps as soon as a species discovers EBMC2, it starts a countdown clock to nuclear annihilation. Perhaps as soon as a species invents synthetic biology, it inevitably creates a plague that wipes it out. Perhaps as soon as a species creates AI, it is replaced. Or maybe it is a resource crisis. A civilization burns through its planet's fossil fuels to build a high-tech society, but runs out of energy before it can build the spaceships needed to leave, trapping it on a dying world forever. In this scenario, we are not special. We are not the chosen ones. We are just the latest batch of cattle entering the chute. We look at our technological progress, our smartphones, our rockets, our particle accelerators, and we feel proud. We think we are conquering nature. But if the filter is ahead, then our progress is just accelerating us toward the wall. Every scientific breakthrough brings us closer to the weapon, or the mistake that will end us. This theory transforms the great silence into something truly horrifying. The silence is not because we are the first to arrive. The silence is the sound of 1 billion species hitting the wall at full speed. It is the echo of 1 billion civilizations that reached our level of sophistication, looked at the stars, prepared to launch, and then tripped on the exact same wire we are about to cross. They all thought they were special. They all thought they would be the ones to make it. And they are all gone. The silence is the sound of the graveyard filling up, and we are just the next funeral procession marching toward the open grave. If the filter is ahead, then our optimism is a fatal flaw. We are like a turkey being fed every day by a farmer. To the turkey, the farmer is a benevolent god who provides food and safety. The turkey's life gets better every single day. The statistics of its life point to a graph that only goes up. Until Thanksgiving. The turkey cannot foresee the butcher because its past experience does not include the concept of slaughter. We look at our history of survival and assume it will continue, but the great filter says that the butcher is waiting, and we are fattening ourselves up for the kill. This brings us to one of the most counterintuitive and frankly most depressing arguments in the history of scientific philosophy. It was proposed by the philosopher Nick Bostrom, a man whose job is to think about the potential ends of humanity. His argument turns our most hopeful dreams of exploration into a nightmare. It turns the entire mission of NASA on its head. Right now, as you listen to this, billions of dollars are being spent by the space agencies of the world, NASA, the European Space Agency, China, India, to send rovers and probes to our neighbours. We are obsessed with Mars. We are drilling into the red dirt with robots like Perseverance and Curiosity. We are planning missions to drill through the ice of Europa and Enceladus. We are looking for one thing. We are desperate to find a single sign of life. We are hunting for a fossilized microbe, a trace of ancient bacteria, or a chemical signature that proves biology once existed there. We think that finding proof of alien life would be the greatest discovery in human history. We think it would be a moment of global celebration. We imagine headlines screaming, "We are not alone." We imagine it would unite us, give us perspective, and prove that the universe is a living, breathing place. But Nick Bostrom argues that it would actually be the worst news ever printed on the front page of a newspaper. He famously wrote a paper titled, "Why I Hope the Search for Extraterrestrial Life Finds Nothing." He argues that the silence of the night sky is golden. He argues that we should hope, with all our hearts, that Mars is a barren, dead rock. We should hope that the oceans of Europa are sterile water and nothing else. We should hope that we are the only living things for 1 billion light years. Here is why. The Great Filter is a probability game played on a galactic scale. We know 2 things for sure. 1. There are no starfaring civilizations visible in the sky. The galaxy appears empty. 2. We exist. This means that somewhere between dead rock and galactic empire, there is a wall that stops the process. There is a filter. The question is, where is the wall? If we go to Mars, a planet right next door, a planet that is very similar to Earth but separate, and we find that life evolved there independently, it changes the variables of the equation. If life started twice in just one single solar system, then statistically it must be common. It implies that the emergence of life is not a miracle. It is a default setting of the universe. It means that if you roll the dice on a planet, you almost always get biology. If finding life on Mars tells us that the first step on the ladder, abiogenesis, is easy, then the Great Filter cannot be in our past. If everyone starts the race and nobody finishes it, then the trap must be near the finish line. The more complex the life we find on Mars, the worse the news is for us. It is a sliding scale of doom. If we find simple bacteria, it is bad. It means that 99% of planets develop life, but we still don't see any aliens. That means the filter is somewhere after the bacterial stage. Maybe it's the jump to multicellular life. Maybe it's the jump to intelligence. We might still be safe, but the odds just got worse. If we find fossils of complex animals, creatures like fish or reptiles or plants, it is catastrophic. It means that life doesn't just start easily, it evolves easily. It means that the difficult steps of evolution that we thought we survived were actually just simple hops that everyone makes. It means the filter is not behind us. It pushes the probability of the filter being in our future to near 100%. And if we find the ruins of an ancient civilization, that is the death sentence. Imagine digging into the Martian sand and finding a stone tool, or a gear, or the foundation of a building. Imagine finding evidence that a species on Mars discovered mathematics, built cities, and perhaps even launched rockets before they went extinct. It would prove that climbing the ladder is easy. It would prove that technology is not a shield against the filter. It would prove that millions of species have made it exactly as far as we have. They evolved, they built tools, they looked at the stars, they developed industry, and then they vanished. They hit the wall. Finding ruins on Mars would be absolute proof that we are walking into a meat grinder. It would mean that there is a strict universal law that prevents civilizations from reaching the next level. It would mean that the Great Filter is waiting for us, perhaps just a few centuries or even a few decades away. It would imply that there is something inherent in the process of becoming a high-tech civilization that ensures self-destruction. If we find a dead civilization next door, we are looking at our own reflection in a mirror. We are looking at our own future. It would mean that the silence of the universe is not because life is rare, but because life is self-terminating. This is why the silence is golden. Silence means we might be special. Silence means we might be the only ones who have made it this far, which means the hard part might be over. We want the universe to be empty. We want to be the lonely miracle. Because the alternative is that the universe is a crowded factory that produces civilizations just to slaughter them. So, when the next rover lands, do not cross your fingers for life. Do not hope for a breakthrough. Pray for rocks. Pray for dust. Pray for radiation and dead chemistry. Pray for a sterile, lonely, empty universe. Because a dead universe means we still have a chance to fill it. A living universe means we are already walking dead, marching toward a grave that has already been dug for us by the laws of probability. We are safe as long as we are alone. The moment we find a friend, we find our doom. To understand the next theory, we must first fast forward to the very end of the story. We must travel to the deep, distant future, long after the era of humanity has been forgotten, and long after the stars have ceased to shine. We have to talk about entropy. We have to talk about the heat death of the universe. The second law of thermodynamics is arguably the most depressing rule in all of physics. It acts as the arrow of time. It states that in a closed system, entropy, which is a measure of disorder, always increases. Things break. Buildings crumble into sand. Hot coffee gets cold. Complex structures degrade into simple dust. Energy spreads out. The universe is marching inevitably from a state of low entropy, the organized structure of the Big Bang, to a state of high entropy, a chaotic, uniform mush of cold radiation. Eventually, trillions upon trillions of years from now, the universe will reach a state of maximum entropy. This is the heat death. All the stars will have burned out. All the galaxies will have drifted apart. Even the black holes will have evaporated via Hawking radiation. Space will be an endless, frozen void, a sea of absolute darkness filled with nothing but drifting particles and low-energy photons. The temperature will be absolute zero. Time, for all intents and purposes, will stop, because nothing will ever happen again. Or so we thought. Here is where the laws of physics play a trick on us. In the world of quantum mechanics and statistical thermodynamics, nothing is never really nothing. Even in a perfect vacuum, even in the dead silence of the heat death, the universe is not empty. It is filled with fields, and these fields are subject to quantum fluctuations. Particles pop in and out of existence. Energy shifts and vibrates. The vacuum is a roiling sea of potentiality, and while the universe will be dead, it will also be eternal. It will have an infinite amount of time to sit there in the dark, and this concept, infinity, is the key that unlocks the madness. When you have an infinite amount of time, the word impossible loses its meaning. It is replaced by the word inevitable. You have probably heard of the infinite monkey theorem. It is a famous thought experiment used to illustrate the nature of probability and eternity. It states that if you sit a monkey in front of a typewriter and let it hit the keys at random, it will produce a lot of gibberish. It will type AGFDH and KLJFSD. But if you give that monkey an infinite amount of time, if you let it type forever, statistically, eventually, purely by accident, it will type the word "the." If you wait longer, it will type the sentence, "The quick brown fox jumps over the lazy dog." And if you wait an eternity, the random combination of keystrokes will, at some point, perfectly reproduce the complete works of William Shakespeare. It won't know what it is doing. It won't have any intent. It will just be a statistical accident. The monkey will type Hamlet, Romeo and Juliet, and Macbeth in perfect order, comma for comma, letter for letter, simply because every possible combination of letters must eventually happen in an infinite timeline. Now, we're going to take this theorem and apply it to the cosmos. Replace the monkey with the vacuum of deep space. Replace the typewriter with the laws of quantum mechanics, and replace the letters with atoms. In the dead universe, particles are drifting randomly. They are bumping into each other. They are fluctuating. Most of the time, for billions and trillions of years, they just drift apart. The entropy remains high. The chaos remains chaotic. But, according to the laws of statistical mechanics, there is a non-zero probability that a group of atoms will randomly bump into each other and stick. Usually this will form a speck of dust, maybe a hydrogen molecule, nothing interesting. But remember, we have forever. We have a timeline that never ends. So the dice are being rolled an infinite number of times. If you wait long enough, and we are talking about timescales so vast that scientific notation breaks down, numbers like 10 to the power of 10 to the power of 50 years, the random jittering of particles in the void will accidentally arrange themselves into a structure. Suddenly, out of the sheer chaos of the thermal bath, order appears. It is a reversal of entropy, but it is allowed because it is a temporary fluctuation. It is like shaking a box of Scrabble tiles for 1 billion years and suddenly looking down to see that they have spelled your name. If you wait long enough, the atoms might randomly assemble into a functioning pocket watch. It would tick for a few seconds before dissolving back into the void. If you wait even longer, they might assemble into a perfect fresh apple. If you wait longer still, they might accidentally form a fully functioning solar system, complete with planets and moons, that exist for a few million years before falling apart. This is not science fiction. This is Ludwig Boltzmann's interpretation of thermodynamics. It suggests that order is not a divine creation, but a statistical inevitability. Given enough time, chaos will hallucinate reality. The universe isn't dead, it is dreaming. And in those dreams, it creates things, horrifyingly complex things. And this leads us to the most disturbing question of all. What is the most complex thing that atoms can create? It isn't a watch, it isn't an apple, it is the machine that perceives them, it is the brain. And that is where the nightmare truly begins. This leads us to a paradox that breaks the foundations of cosmology. If we accept the laws of thermodynamics, and we accept that the universe will last forever in a state of high entropy, then we have to accept the math of fluctuations. And the math tells us something disturbing about the cost of reality. Think about how expensive our current universe is in terms of entropy. For you to exist right now in the way you think you do, the universe had to perform a miracle of organization. It had to create the Big Bang, a moment of infinitely low entropy. It had to create the laws of physics. It had to forge hydrogen and helium. It had to pull those gases together to form stars. It had to explode those stars to create carbon, nitrogen and oxygen. It had to form a planet. It had to evolve life over 4 billion years through endless cycles of death and selection just to produce the specific biological machine that is your body. And it had to sustain that body with food, water and atmosphere every single day of your life. That is a fluctuation of colossal, almost impossible size. It is an intricate, heavy, expensive chain of causality. It is like rolling a trillion six-sided dice and having them all land on 6 at the exact same time, continuously, for billions of years. But think about what is actually required for your experience of reality. What do you actually need to feel like you are here? You don't actually need the galaxies. You don't need the stars. You don't need the planet Earth. You don't even need your body. All you need is your brain. Your consciousness is just a specific configuration of atoms processing electrical signals. Your perception of the chair you're sitting on is just a signal firing in your parietal lobe. Your vision of the screen is just a pattern in your visual cortex. Your memory of your childhood is just a specific arrangement of proteins and connections in your hippocampus. Reality, as far as you're concerned, is contained entirely within the 3 pounds of wet matter inside your skull. So ask yourself, from a statistical standpoint, what is more likely? Is it more likely that the universe performed the impossible, expensive miracle of creating a Big Bang and 14 billion years of consistent history? Or is it more likely that the random chaos of the void accidentally arranged a small clump of atoms into the shape of a brain for just a few seconds? Thermodynamics gives a clear, brutal answer. It is exponentially more likely for a single brain to spontaneously fluctuate into existence out of the void than for a whole universe to evolve. It is infinitely cheaper for nature to build the observer than it is to build the world the observer sees. The universe is lazy. It takes the path of least resistance. And the path of least resistance is to hallucinate you, rather than to grow you. This theoretical entity is called a Boltzmann brain. It is a freak accident of matter, a disembodied mind floating in the deep freeze of the eternal night. And the most terrifying part of this theory is not the isolation, it is the continuity. When a Boltzmann brain snaps into existence out of the void, it doesn't wake up confused. It doesn't feel like a newborn baby. It wakes up fully loaded. The random arrangement of neurons that formed it includes a detailed, complex and completely false backstory. You see, to be conscious in the present moment, you need context. You need to know who you are. You need to know where you are. And the atoms that form the brain just happen to fall into the configuration that holds those specific memories. A Boltzmann brain has memories of a mother and a father who never existed. It has memories of a first kiss that never happened. It has memories of scraping its knee on a playground that was never built. It remembers the smell of rain, the taste of coffee, and the warmth of the sun. But there is no rain, there is no coffee, there is no sun. These are just data corruption. They are random patterns of electrons that the brain interprets as history. The brain feels, with absolute certainty, that it is a human being living a normal life. It feels the weight of gravity, even though it is floating in zero-gravity space, because the neurons governing its sense of balance are firing in a specific way. It sees light, even though it is in absolute darkness, because its visual cortex is being stimulated by random thermal noise. It feels the passage of time, even though it has only existed for a microsecond. It is the ultimate solipsistic nightmare. The Boltzmann brain is a prisoner of a hallucination so perfect that it cannot be distinguished from reality. It believes it has a past. It believes it has a future. It worries about its job. It loves its children. It has political opinions. It fears death. But none of those things are real. They are just the fever dream of a dying cluster of atoms. The brain is a freak observer. It is a glitch. It is a momentary flash of order in a sea of chaos. It appears, it thinks I am. It remembers a life that never was, and then the fluctuation decays. The atoms drift apart. The brain dissolves back into the radiation. The thought is cut off mid-sentence. The universe returns to silence. It is a horror story that happens in the blink of an eye. But for that one blink, the horror is absolute, because the victim believes it is the protagonist of a story that spans eons, and the math suggests that this isn't just possible. It suggests that this is the standard way consciousness exists in our universe. I want you to stop looking at the video for a moment. I want you to look away from the screen, look at your hands, turn them over, look at the lines on your palms, the texture of your skin, the slight tremor in your fingers. Now, look around the room you are in. Look at the walls. Look at the light-casting shadows on the floor. Listen to the hum of the world around you, the traffic outside, the fan of your computer, the beating of your own heart. It feels real, doesn't it? It feels solid. It feels undeniable. You're completely, 100% convinced that you are a biological human being, sitting in a room on planet Earth, watching a documentary about scary physics theories. You are secure in the knowledge of your own history. You know who you are, but I need you to understand something. I need you to really hear me. That feeling of solidity, that sense of history, it proves absolutely nothing. The Boltzmann brain theory is not a story about something that might happen in the future. It is a story about you, right now. The mathematics of the theory are indifferent to your feelings. They are indifferent to how real this moment feels. If the universe lasts forever, and the evidence suggests it will, then the number of conscious minds that arise from random fluctuations in the void will outnumber the number of conscious minds that arise from biological evolution by a factor of infinity to 1. Think about those odds. Infinity to 1. If you were to reach into a bag containing one green marble and an infinite number of red marbles and you pulled one out, which colour would it be? It would be red. Every single time for eternity it would be red. To pull the green marble, the real human life, would be a statistical miracle so impossible that it effectively cannot happen. So why are you so arrogant as to assume that you are the green marble? Why do you assume you are the biological exception? Because you have memories? Because you remember waking up this morning? Because you remember your childhood home and the name of your first pet and the taste of your favourite food? Let me tell you a secret about memory. Memory is not a recording. It is not a video file stored on a hard drive that you play back. Memory is an active chemical process happening in the present tense. When you remember your childhood, you're not accessing the past. You're assembling a story right now. In this second, your brain is firing a specific pattern of neurons to create the illusion of a timeline. A Boltzmann brain formed in the void comes preloaded with those exact same patterns. It has the exact same electrical signals. If you were a Boltzmann brain that just fluctuated into existence 1 second ago, you would have a perfect, vivid memory of reading the title of this video and clicking on it. You would have a perfect memory of the last 5 minutes of this audio. You would have a perfect memory of your entire life leading up to this moment. But none of it happened. You didn't click the video. You didn't wake up this morning. You didn't grow up. You didn't exist. There was no yesterday. There was no 5 seconds ago. There is only now. The universe is just a cold, silent soup of radiation, and you are a momentary spark of hallucination floating in the dark. The room you see around you is a mirage. The screen you are reading is a mirage. The body you feel you are inhabiting is a phantom limb. You are alone. You're floating in a void so vast and so dark that the human mind cannot comprehend it, dreaming of a life that is colourful and warm. And the most terrifying part, the fluctuation is unstable. A Boltzmann brain cannot sustain itself. The entropy is too high. The chaotic forces of the void are already tearing at the edges of your consciousness. The order that created you is slipping back into disorder. This means that you're not just a fake observer, you are a dying one. Your entire existence, this whole life you think you have led, is likely just a momentary flash. It lasts for a few seconds, just long enough to think, I am. Just long enough to feel confused, just long enough to hear a voice telling you that you aren't real. And then it ends. Are you sure you are reading this? Are you sure you haven't just hallucinated the beginning of this sentence? Are you sure you will make it to the end of this sentence? If the theory is correct, the dissolution could happen at any moment. The coherence of your mind will simply fail. The walls of your room will dissolve into static. The memory of your family will evaporate like smoke. The concept of Earth will be deleted from your mind, replaced by the freezing cold of the vacuum. You will not die because you never lived. You will simply stop dreaming. You might be thinking, this is ridiculous. I know I am real. I can feel the table. I can pinch myself. But that is exactly what the brain would think. That is exactly what the fluctuation is programmed to simulate. The simulation of pain is just information. The simulation of doubt is just information. You cannot use your own mind to prove your own mind exists. You are trapped in a closed loop of logic. So take a deep breath. Hold it. Feel the air filling your lungs. Is it air, or is it just a random assembly of atoms mimicking the sensation of pressure? You will never know. You can never know. You're trapped in the prison of your own consciousness, and the walls are closing in. The only thing you can trust is that something is experiencing this moment, but everything else, the past, the future, the world, the stars, the people you love, is a statistical lie, and the lie is about to unravel. The void is waiting. The silence is coming back, and this time it will be forever. Deep in the graveyard of the cosmos, amidst the wreckage of supernovae and the silent drifting dust of dead solar systems, there are the corpses of giant stars known as neutron stars. To call them stars is a linguistic failure. It implies they are like our sun, balls of gas burning bright, giving life. They are not. They are cities of nuclear fire compressed into a ball the size of a small island. They are the dense iron cores of what used to be titans, now crushed by their own weight into objects of such terrifying density that the human mind struggles to process the numbers. Imagine the island of Manhattan, every building, every subway tunnel, every person, every car, every chaotic atom of that city. Now, imagine a giant invisible hand squeezing Manhattan. It crushes the skyscrapers. It crushes the bedrock. It crushes the space between the atoms. It squeezes until the entire island is the size of a grain of sand. That is the density of a neutron star. A single teaspoon of its material would weigh 1 billion tons. If you were to drop that teaspoon on Earth, it wouldn't just sit on the ground. It would punch through the crust, the mantle, and the core like a bullet through a sheet of paper, tearing a hole through the planet. The gravity on the surface of a neutron star is 200 billion times stronger than Earth's. If you were to drop a marshmallow from a height of 1 meter above the surface, it would hit the ground with the kinetic energy of a nuclear bomb. The surface is a smooth, perfect sphere of iron crystal, harder than diamond, glowing with a lethal X-ray heat. But the true horror of a neutron star is not what happens on the surface, it is what happens inside. To understand the nightmare that is brewing in the core, we have to look at the fundamental building blocks of reality. We have to look at quarks. Everything you have ever touched, seen or loved is made of atoms, and atoms are mostly empty space with a tiny nucleus in the center made of protons and neutrons. If you crack open a proton or a neutron, you find the true fundamental particles, quarks. In our universe, the safe universe, there are only 2 types of quarks that matter for stable structures. We call them the up quark and the down quark. They are the Lego bricks of existence. A proton is 2 ups and 1 down. A neutron is 2 downs and 1 up. Every star, every planet, every drop of water, and every strand of your DNA is just a remix of these 2 simple ingredients. Up and down. Positive and negative. Yin and yang. They are stable, reliable, and they follow the rules. They are the normal setting of the universe. But inside the core of a neutron star, the pressure is so extreme that the rules of the game change. As you descend through the crust of the star, the atoms are crushed together. The electrons are squeezed into the protons, turning them into neutrons. Eventually, there are no atoms left. There is just a sea of neutrons packed shoulder to shoulder, screaming under the weight of a dying star. This is called neutronium. But go deeper. Go to the very centre. The pressure here is beyond calculation. It is higher than the pressure inside an atomic nucleus. It is a pressure that grinds the fabric of matter itself. Here, the neutrons themselves begin to panic. They are being pushed so close together that their boundaries dissolve. They melt. They lose their individual identity. The bags holding the quarks together rip open. Suddenly you don't have neutrons anymore. You have a quark-gluon plasma. You have a soup of free-floating up and down quarks. And under this extreme, hellish compression, something strange happens. The energy level is so high that some of the down quarks are forced to mutate. They undergo a quantum metamorphosis. They change their flavour. They turn into a third type of particle, a particle that has no business existing in a stable rock, the strange quark. The strange quark is the heavy, monstrous cousin of the down quark. It is much more massive. In our normal world, strange quarks are unstable and decay almost instantly. They are ghosts. But inside the pressure cooker of the neutron star, the strange quark finds a home. It stabilizes. When you mix up, down, and strange quarks together in this super dense soup, they form a new substance. This is not a gas. It is not a liquid. It is not a solid. It is a completely new state of matter called strange matter. And this is where the physics turns into a horror story. According to the hypothesis, strange matter is not just a weird byproduct. It is perfect. You see, normal matter, the up and down quarks that make up your body, is actually struggling. It is under tension. It is anxious. It wants to find a lower energy state, but it can't. But strange matter is relaxed. The addition of the strange quark makes the arrangement mathematically perfect. It is the ground state of the universe. It is the absolute bottom of the energy valley. Think of normal matter like a rock balanced on the side of a hill. It is stable for now, but it secretly wants to roll down. Strange matter is the rock at the bottom of the hill. It is where all matter secretly wants to be. It is the ideal form of existence that the universe has been trying to achieve since the Big Bang. Inside the core of the neutron star, this strange matter sits there, locked away by the immense gravity, burning with a dark, heavy perfection. It is a seed of ultimate stability, a drop of poison in the cosmic well. As long as it stays inside the star, we are safe. It is trapped in its gravity prison. But the universe is a violent place. Stars collide, gravity wells break, and sometimes the prison walls crack open and the monster inside gets a chance to escape. And because it is the perfect form of matter, it has a terrifying property. It doesn't just want to exist, it wants to convert. It is contagious, and that contagion is the subject of our next nightmare. Ideally, this nightmare substance would stay locked inside the gravity well of the neutron star forever. It should remain buried in the dark, crushed under the weight of a dying sun, never to interact with the delicate biology of the rest of the cosmos. But the universe is a violent, chaotic, and messy place. It does not respect quarantine zones. Neutron stars do not just sit there in isolation. They are social objects. They often exist in binary pairs, two dead stars orbiting each other in a frantic, decaying spiral. Over millions of years, they bleed energy in the form of gravitational waves. They inch closer and closer together. Their orbital speed increases until they are moving at a significant fraction of the speed of light. And finally they collide. This event is called a kilonova. It is one of the most violent events in nature, second only to the Big Bang itself. When these two city-sized balls of nuclear density smash into each other, they don't just crack, they liquefy. They shatter the fabric of space-time, and in the violence of the merger they vomit their guts out into the void. Vast amounts of neutron-rich material are sprayed into the galaxy like a cosmic shotgun blast. Most of this material rapidly decompresses and decays, transforming into heavy elements. In fact, the gold in your wedding ring, the platinum in your catalytic converter, and the uranium in our nuclear missiles were likely forged in one of these collisions. We love neutron star collisions because they give us our precious metals. But in the chaos of the spray, some chunks of the core might survive intact. Some fragments of the strange matter might be ejected before they can decay. These fragments are called strangelets. And they are, theoretically, the most dangerous objects in the universe. A strangelet is essentially a subatomic asteroid. It is a cluster of strange matter that has broken free from its parent star. It could be microscopic, no bigger than a single atom. It could be the size of a marble, or it could be a massive chunk the size of a mountain. But regardless of its size, its nature remains the same. It is a nugget of absolute physical perfection. To understand why perfection is a threat, you have to understand the motivation of matter. Every object in the universe, from a falling rock to a chemical bond, is driven by a single desire: the desire to lose energy, the desire to relax, the desire to find stability. Think of a ball rolling around in a bowl. It will eventually settle at the absolute bottom. It wants to be there. It requires energy to lift it up the sides, but it requires zero energy to stay at the bottom. The bottom of the bowl is the ground state. It is the preferred location of existence. The protons and neutrons that make up your body, the normal matter of the universe, are not at the bottom of the bowl. They are partway up the side. They are stable-ish, but they are not perfect. They are holding on to extra energy. They are stressed. The arrangement of up and down quarks is functional, but it is not optimal. It is like a suitcase that has been packed in a hurry. You can zip it shut, but the clothes are wrinkled and the seams are straining. Strange matter, however, is the bottom of the bowl. The mathematical models of quantum chromodynamics suggest that a mixture of up, down, and strange quarks is the true ground state of hadronic matter. It is the perfectly packed suitcase. Because there are 3 types of quarks instead of 2, the Pauli exclusion principle, a rule that says particles can't sit in the same seat, is less restrictive. The quarks can pack tighter. They can sit closer together. The binding energy holding them together is stronger than anything in the normal world. This makes a strangelet effectively indestructible. You cannot break it. If you hit a diamond with a hammer, it shatters because the carbon atoms can be forced apart. If you hit a strangelet with a hammer, the hammer would simply bounce off or be destroyed. Because the strangelet is bound by the strong nuclear force, the most powerful force in nature, optimized to its maximum efficiency. You cannot melt it, because it was born in temperatures hotter than a supernova. You cannot dissolve it in acid. You cannot blow it up with a nuclear bomb. In fact, if you detonated a nuke next to a strangelet, it wouldn't be damaged. It would probably just absorb the energy and get slightly bigger. It is an invincible bullet drifting through the galaxy. It has no expiration date. It does not decay like radioactive uranium. It does not rust like iron. It does not evaporate like water. A strangelet created 10 billion years ago in a distant galaxy is still floating out there today, exactly as potent as the moment it was born. It is an eternal object, and because it is so small and so dense, it is invisible. It does not emit light. It does not reflect radar. It creates a gravitational field so small that we cannot detect it until we are right on top of it. It is just floating there, in the silence between the stars, moving at thousands of miles per second. It is a cosmic landmine waiting for a ship or a planet or a star to drift into its path. But the physical impact of a strangelet is not the problem. If a microscopic bullet hits the Earth, it creates a small crater. We can survive a crater. We can survive an impact. The horror of the strangelet is not its momentum. The horror is its hunger. Because it is the perfect form of matter, it has a terrible, godlike quality. It wants to share its perfection. It is not just a rock. It is a template. It is a seed. And when it touches imperfection, when it touches normal matter like us, it does not just sit there. It teaches us how to be perfect too. And perfection, in this context, means death. This is where the theory ceases to be a discussion of astrophysics and transforms into a story of contagion. It is the ultimate cosmic horror because it combines the violence of a nuclear bomb with the silence of a virus. Imagine a single strangelet, a microscopic fragment of a dead star drifting through the vacuum. It has travelled for 1 billion years. It has passed through the hearts of nebulae and the arms of spiral galaxies. It enters our solar system. It is too small to reflect sunlight. It is too heavy to be pushed aside by the solar wind. It falls toward Earth, pulled by our gravity, a silent assassin dropping from the dark. It hits the atmosphere. It creates no streak of fire. It does not burn up because it is already more stable than the heat of re-entry. It punches through the air molecules like a bullet through fog. It could land anywhere. It could land in the middle of the Pacific Ocean. It could land in the Sahara Desert. It could land in your backyard. For this scenario, Let us imagine it lands in a standard suburban garden. It hits the soil. The moment of contact is the beginning of the end. The strangelet is a seed of the true ground state. When it touches the nucleus of a silicon atom in the dirt, a catastrophic negotiation takes place. The up and down quarks inside the silicon nucleus feel the presence of the strange matter. They sense the deep, stable energy valley of the strangelet. They are like water hovering on the edge of a drain. They cannot resist the pull of the lower energy state. Instantly, the silicon nucleus collapses. Its quarks rearrange. They convert into strange matter to match the invader. The silicon atom ceases to exist. It becomes a larger piece of the strangelet. This conversion process releases energy. When matter settles into a lower energy state, it must shed the excess binding energy. This energy is released as heat and gamma radiation. So the first thing that happens is a flash of light, a microscopic spark. But the spark is not the danger. The danger is that the strangelet has just grown. It was the size of one atom, now it is the size of two. Now, the surface area of the strangelet is larger. It touches the oxygen atoms next to the silicon. They convert. Then the nitrogen. Then the carbon. It is a runaway nuclear chain reaction, but it is not fission and it is not fusion. It is strangelet catalysis. It acts exactly like the mythical curse of King Midas, who turned everything he touched into gold. But instead of gold, the Earth is being turned into a hyperdense, searingly hot sludge of subatomic particles. The reaction spreads outward from the impact point. It does not move at the speed of light. It moves at the speed of sound, or perhaps faster through the rock. The ground begins to burn. But this is not a chemical fire. It is a nuclear transmutation. The soil glows with a blinding blue-white intensity. And then the horror begins. The ground starts to fall. Strange matter is billions of times denser than normal matter. As the rock and dirt are converted, they take up a fraction of the space they used to occupy. The volume of the Earth is being deleted. The garden where the strangelet landed collapses into a pit. Then the neighbourhood falls in. It is a sinkhole that grows exponentially, eating the crust of the planet. Within minutes, the reaction digs down. Gravity pulls the heavy strangelet clump toward the centre of the Earth. It melts its way through the crust and mantle like a ball of red-hot steel dropping through a block of wax. As it falls, it eats. It consumes the magma. It consumes the iron core. It grows massive. On the surface, panic sets in. Earthquakes begin to shatter the tectonic plates. The planetary balance is destroyed, but the real destruction comes from the volume loss. As the core of the Earth is converted into strange matter, the planet begins to shrink. The diameter of the world contracts. The crust, no longer supported by the mantle, crumbles inward. The oceans pour into the gaping wounds of the planet, boiling away into steam as they hit the exposed, glowing core of strange matter. The atmosphere, suddenly finding itself surrounding a much smaller object, becomes turbulent. Hyperhurricanes scour the surface. But the wind doesn't matter, because the ground itself is being consumed. The contagion spreads from the core outward. The entire planet is being pulled inside out. It is collapsing into a sphere roughly 100 meters across. This is the ultimate fate of the Earth. It does not explode. It implodes. Mountains, cities, forests, and oceans are sucked into the growing ball of strange matter. The entire process might take an hour, maybe less. The density of the object becomes so high that the gravity on its surface becomes crushing. If you were standing on the edge of the contagion, you wouldn't just be burned. You would be spaghettified, pulled apart by tidal forces and added to the soup. At the end of the hour, the Earth is gone. The Moon is still orbiting, but it is now orbiting a tiny, incredibly heavy, glowing marble. There is no blue. There is no green. There is only a sphere of strange matter spinning rapidly in the silence, radiating the heat of the consumed world. The strangelet has won. It has successfully converted a massive unstable object into a perfect stable one. It is a better version of Earth, according to the laws of physics. It is calm, it is eternal, it will never decay. And now it is a loaded gun, because this new, Earth-mass strangelet is much bigger than the original seed. It is a massive target for asteroids. Eventually a rock will hit it, and when it does, it will chip off pieces. It will send new showers of microscopic strangelets flying out into the solar system. Maybe one will hit Mars, maybe one will hit Jupiter, maybe one will be flung out into the galaxy to find another solar system and start the process all over again. The infection spreads. The universe slowly, atom by atom, star by star, is converted into a cold, perfect, dead graveyard of strange matter. This is the grey goo scenario of astrophysics, and there is absolutely nothing we can do to stop it. We just have to hope that the perfection of the universe stays locked away in the hearts of the stars and never comes to visit us. We are taught from a very young age that the universe is expanding. We are shown the image of a balloon being inflated, with galaxies painted on the surface like little dots. As the balloon gets bigger, the dots move away from each other. This is the standard model of cosmology. It paints a picture of a lonely, dignified, and aimless drift. It suggests that we are moving outward into the void, separated from our neighbours by the stretching of space itself, destined to float in isolation forever. It is a sad image, but it is a peaceful one. It implies a certain kind of freedom. It implies that we are not bound to anything, that we are just drifting on the calm surface of an infinite expanding ocean. But this picture is a lie, or, at the very least, it is a convenient oversimplification that hides a much more violent truth. When astronomers began to map the movement of the galaxies in our local neighbourhood, not just their redshift due to expansion, but their actual peculiar velocity through space, they noticed something wrong. They subtracted the expansion of the universe from the data, expecting to see random, chaotic motion. They expected to see galaxies buzzing around like bees in a jar, with no particular direction. But that is not what they found. They found a current. Imagine you are swimming in the middle of a vast blue ocean. The water is calm, the sun is shining, you feel like you are just bobbing up and down, drifting wherever the wind takes you. But then, you look down at the water. You notice that the seaweed, the debris and the bubbles are all rushing past you. You look at the other swimmers, distant galaxies like Andromeda, the Triangulum galaxy, and the millions of stars in the Virgo cluster, and you realise that they are not drifting randomly. They are all moving in the exact same direction. They are locked in formation. You are not in a calm ocean, you are in a river, and the river is moving fast. We are caught in a gravitational riptide of unimaginable scale. Our entire galaxy, the Milky Way, this disk of 100 billion stars with all its planets, all its nebulas and all its black holes, is surfing on a wave of gravity, and we are moving with terrifying speed. The measurements are precise and undeniable. We are hurtling through the intergalactic void at a speed of 600 kilometers per second. Let me put that number into perspective for you. That is 1.3 million miles per hour. In the time it took you to read this sentence, we have travelled thousands of miles. We are moving faster than a bullet. We are moving faster than an explosion. We are moving faster than any rocket humanity has ever dreamed of building. If you could stand outside the universe and watch, you would see a stream of galaxies, millions of light years wide, flowing like water down a drain. This structure is known as Laniakea, a Hawaiian word that means immeasurable heaven. It is a supercluster of galaxies, a watershed of cosmic proportions. And just like raindrops falling on a mountain range eventually find their way into a river, every galaxy in our corner of the universe is being funneled into this massive invisible stream. This is not the gentle expansion of the Big Bang. This is a targeted trajectory. This is a fall. Gravity is the only force in the universe capable of moving objects this heavy. You cannot push a galaxy, you have to pull it. And to pull the Milky Way, Andromeda, and thousands of other galaxies at this velocity requires a mass that defies comprehension. It requires a gravitational generator so powerful that it makes our supermassive black hole look like a single grain of sand. We call this mysterious destination the Great Attractor. We don't know exactly what it is, but we know it is there because we can feel its grip on our atoms. We are falling toward it. The sun is falling. The earth is falling. You are falling. We are rushing headlong through the dark, dragged by a monstrous hand, toward a meeting point hundreds of millions of light years away. And the reason this feels like vertigo, the reason this should make you grip the arms of your chair, is because of the sheer helplessness of it. We like to think we are explorers. We build ships to go to Mars. We talk about interstellar travel. But these are the movements of ants crawling on a leaf that is being thrown over a waterfall. It doesn't matter where we drive our little rovers. It doesn't matter if we colonize the galaxy. The galaxy itself is a passenger. We are not driving the bus. We are locked in a trunk, speeding down a highway we cannot see, toward a destination we did not choose, pulled by a force we cannot fight. The universe is not static. It is kinetic. It is a machine of perpetual motion, and we are just gears grinding inside it. We are rushing toward a specific point in the sky, a point located in the direction of the constellations Hydra and Centaurus. Something is waiting for us there, something massive enough to eat galaxies. And the most terrifying part of this cosmic horror story isn't the speed, it isn't the size. It is the fact that when we look out the front window of our spaceship to see what is pulling us, we see nothing. The windshield is black. We are rushing at 1,000,000 miles an hour toward a monster that is hiding in the one place we cannot look. There is a cosmic irony at play here that feels almost malicious. It is a joke played on humanity by the geometry of the universe. We are the most observant species that has ever existed on this planet. We have built eyes of glass and metal that can peer into the very dawn of time. We have telescopes like Hubble and James Webb that can resolve the structure of galaxies 13 billion light-years away. We can map the cosmic microwave background, the afterglow of the Big Bang itself. We can see quasars on the edge of the observable universe. We have mapped the heavens with a level of precision that would look like witchcraft to our ancestors. But the one object that matters the most, the one object that has its hands around the throat of our galaxy, happens to sit in the one distinct blind spot in our sky. It is hidden in the one place we effectively cannot look. Astronomers call this region the zone of avoidance. It sounds like something from a science fiction horror movie, a sector of space forbidden to travellers, but it is a legitimate scientific term. It refers to the area of the sky that is obscured by our own galaxy. To understand why this blind spot exists, you have to understand the shape of your home. The Milky Way is a spiral galaxy. It is shaped like a flat disk, like a pancake or a DVD. We do not live in the centre of this disk. We live out in the suburbs, on one of the spiral arms, about 2/3 of the way out from the core. When we look up or down out of the disk, away from the plane of the galaxy, our view is clear. We are looking into the deep, empty void of intergalactic space, and we can see millions of other galaxies shining clearly in the dark. This is how we mapped the universe. We looked out the windows, but when we try to look through the disk, when we try to look toward the centre of the Milky Way, we hit a wall. If you go out into the countryside on a clear night and look up, you can see this wall with your own eyes. It is the beautiful milky band of light that stretches across the sky. The Greeks called it a river of milk. But to an astronomer, that beautiful band is a prison bar. That band of light is the dense cross-section of our own galaxy. It is packed with billions of stars, but worse than the stars, it is choked with the interstellar medium. This is vast clouds of cosmic dust and gas, nebulae, molecular clouds, the debris of dead stars and the nurseries of new ones. This dust acts like a lead curtain. It is opaque. It absorbs visible light. Trying to see what lies behind the centre of the Milky Way is like trying to see the horizon, while standing in the middle of a dense, foggy forest. You can see the trees right next to you, but beyond a certain point, everything fades into a wall of grey. The dust scatters the photons coming from the other side. The light from the universe behind our galaxy tries to reach us, but it slams into these walls of dust and dies before it hits our telescopes. This region covers about 20% of our night sky. 1/5 of the universe is hidden from us, blocked by the bulk of our own home. And in a twist of fate that defies all statistical probability, the great attractor, the massive, monstrous gravitational anomaly that is dragging us to our doom, sits smack in the middle of that 20%. It is located in the direction of the constellations Hydra and Centaurus, exactly behind the thickest, densest part of the Milky Way's core. We know it is there because we can check the math. We can measure the speed of our galaxy and calculate the mass required to pull us that fast. We can see the galaxies above and below the zone of avoidance bending toward it, like trees leaning in a strong wind. We can map the flow of the river, but we cannot see the waterfall. This creates a sensation of profound helplessness. Imagine you are a passenger in a car. You're strapped into the seat. You can feel the engine vibrating. You can feel the acceleration pushing you back into the cushion. You know you're moving at 100 miles an hour, but the windshield has been painted black. You can look out the side windows and see the scenery rushing by, blurring into streaks. You know you are heading somewhere. You know there is a destination ahead. But you are flying blind. We are hurtling through space at 1.3 million miles per hour toward a collision we cannot predict, pulled by an object we cannot study. We are blindfolded passengers in a runaway solar system. Astronomers have tried to pierce the veil. They have used X-ray telescopes and radio telescopes, which can pass through the dust better than visible light. It is like using radar to see through fog. And they have found things. They have found the Norma cluster, a massive swarm of galaxies. They have found the Shapley supercluster behind that, an even bigger monster. But even these titans aren't enough to explain the speed. The math doesn't balance. There is something else, something bigger, something deeper in the dust. The zone of avoidance remains the ultimate keeper of secrets. It is a reminder that for all our arrogance, for all our technology, and for all our mapping, we are still small. We are still limited by our perspective. We are trying to understand the universe from the inside of a dirty window. And the thing that is eating our future is hiding in the dirt. We are rushing toward a meeting that has been scheduled since the birth of the galaxies, and we won't know the face of our host until we are already inside its mouth. The universe is not just dark, it is actively hiding its monsters from us. So, what is it? What kind of object possesses the gravitational muscle to reel in 100,000 galaxies across hundreds of millions of light-years of empty space? What kind of monster is heavy enough to bend the trajectory of the Milky Way, Andromeda, and the entire Virgo cluster as if we were nothing more than dust motes caught in a vacuum cleaner? For decades, astronomers have been desperate to answer this question. They have peered into the zone of avoidance, trying to map the gravity well that is swallowing us. And every time they think they have found the answer, the mystery only gets deeper and the scale gets larger. At first, they found the Norma cluster. It is a massive swarm of galaxies located near the center of the flow. They thought, this is it. This is the great attractor. It was heavy, it was dense, and it was in the right place. But when they ran the numbers, the math didn't balance. The Norma cluster is heavy, yes. It contains thousands of galaxies. But it is not heavy enough. It is a pebble trying to explain a landslide. The gravitational force required to generate the speed at which we are moving, 600 kilometers per second, is colossal. It requires a mass equivalent to tens of thousands of Milky Ways combined. Norma was just a localized bump in the road. The mountain was still hidden somewhere in the fog, so they looked further. They looked deeper into the dust, hundreds of millions of light years beyond Norma. And there, they found a titan. They found the Shapley supercluster. This is the largest concentration of galaxies in our local universe. It is a sprawling web of matter, a city of light so vast that it makes our own galaxy look like a single atom. It contains more than 8,000 galaxies packed together in a gravitational knot that defies description. It is a monster, and for a few years we thought Shapley was the answer. We thought we had found the drain at the bottom of the bathtub, but even Shapley is not enough. When astrophysicists calculated the mass of the Shapley supercluster and compared it to our velocity, they realized with a sinking feeling that we are moving too fast. Shapley accounts for maybe 40% of the pull, but what about the rest? What is providing the other 60% of the gravity? It means that even the largest structure we have ever seen is just the tip of the iceberg. There is something else behind it, something even bigger, something that dwarfs the largest superclusters we can comprehend. Current theories suggest that the great attractor might not be a thing in the way we understand it. It might not be a ball of stars, it might be a wall. We are starting to realize that the universe is organized into a cosmic web. Galaxies are not scattered randomly. They are strung along filaments of dark matter, like pearls on a necklace. And where these filaments meet, they form walls, sheets of matter stretching across billions of light years. Some cosmologists speculate that we are being pulled by a structure known as the South Pole Wall, or perhaps an even larger structure simply called a cosmic wall. This would be a dense filament of matter stretching across a significant percentage of the observable universe. A structure so vast that it violates the fundamental laws of cosmology, specifically the cosmological principle, which states that matter should be distributed evenly on large scales. If a wall of this magnitude exists, it suggests that the universe is not uniform. It suggests that there are titanic structures, skeletons of the cosmos, that are so big they break our understanding of physics. Or perhaps it is even stranger. Some theories propose that the great attractor is not just a pull, but a push. We have discovered a region of space behind us, on the opposite side of the sky, that is terrifyingly empty. It is a void called the dipole repeller. It is a region of space with almost no galaxies. Because it is so empty, it has very little gravity. This means it doesn't pull on us, but the great attractor in front of us does pull. The result is a push-pull dynamic. We are falling away from the empty void and crashing into the dense wall. We are sliding down a cosmic slope, fleeing the emptiness and racing toward the crunch. Whatever it is, the great attractor serves as a humbling, terrifying reminder of our true status in the universe. We build our little rockets. We burn our chemical fuel. We pat ourselves on the back for landing on the moon or sending a robot to Mars. We think we are mastering flight. We think we are conquering space. But in reality, we are not flying. We are falling. The sun is falling. The Earth is falling. The entire solar system is falling. No matter what we do, no matter how advanced our technology becomes, no matter if we invent warp drives or teleportation, we cannot fight gravity on this scale. We are slowly, inevitably, sliding into the dark. We are being pulled by a hand we cannot see, toward a meeting we cannot escape. We are debris in a flood, and here is the final cruel twist. Because the universe is also expanding, and because that expansion is accelerating due to dark energy, we will likely never reach the great attractor. The space between us and it is stretching faster than we can travel. We are rushing toward it at 1,000,000 miles an hour, but the floor is moving away from us even faster. We are chasing a ghost. We are destined to fall forever, reaching for a monster we will never touch, trapped in an eternal state of high-velocity yearning. We are caught in the flow, drifting towards a horizon that will always remain just out of sight, leaving us with nothing but the sensation of speed and the knowledge that something, out there in the dark, is far, far bigger than we will ever be. And finally, we arrive at the theory that makes all the other theories irrelevant. We have talked about aliens, we have talked about black holes, and we have talked about the collapse of physics. But all of those fears are based on a single, unexamined assumption that the universe is real, that the ground you're standing on is made of matter, that the air you're breathing is made of atoms, and that your consciousness is a biological phenomenon occurring inside a physical brain. But what if it isn't? What if none of this is happening? What if the year is not 2025, but the year 4025? What if you are not a human being made of meat and bone, but a collection of complex code running on a server the size of a planet? This is the simulation hypothesis, and unlike the other theories, this is not based on looking at the stars. It is based on looking at ourselves. It is based on the trajectory of our own technology. And the argument, first proposed by the philosopher Nick Bostrom in 2003, is terrifying not because it is fantastical, but because it is logical. It is a statistical trap that is very, very hard to escape. To understand the trap, you just have to look at a video game. Go back to the year 1972. We had a game called Pong. It was 2 white rectangles and a square dot bouncing between them on a black screen. It was primitive. It was barely recognisable as tennis. Now, fast forward just 50 years. Look at the games we have today. We have virtual reality. We have photorealistic open worlds. We have ray tracing technology that simulates the physics of light bouncing off water. We have millions of players interacting in real time. We have non-player characters driven by artificial intelligence that can hold conversations. That is the progress of just 50 years. Now apply the law of accelerating returns. Project that growth forward. Not 50 years, not 100 years, but 10,000 years, or 1,000,000 years. If computing power continues to grow, even at a fraction of its current speed, eventually we will reach a point where our simulations are not just realistic. They will be perfect. They will be indistinguishable from physical reality. We will be able to simulate every photon, every atom, every gust of wind, and every biological cell. And more importantly, we will be able to simulate minds. We will be able to code consciousness. This is the concept of substrate independence. It suggests that thinking doesn't require wet, squishy neurons. It just requires information processing. If you can replicate the electrical pattern of a human brain inside a computer, that pattern will think, it will feel, it will believe it is alive. This leads us to the concept of the ancestor simulation. Why would a futuristic civilization build a simulation? For the same reason we build them today: research, history, entertainment. A post-human civilization might want to run simulations of their own past to understand how they survived the 21st century. They would spin up a virtual Earth. They would populate it with billions of simulated human beings, us. They would press play and watch history unfold. And because computers are powerful, they wouldn't just run one simulation. They would run millions. They would run variations. What happens if Germany wins World War II? What happens if the pandemic was worse? What happens if humanity solves climate change? They would have millions of servers running millions of different histories, each containing billions of conscious thinking people who have no idea they are code. This brings us to Nick Bostrom's trilemma. It is a logical knife that cuts away our certainty. He argues that one of three propositions must be true. Proposition 1. Intelligent civilizations never reach the level of technology required to run these simulations. This means that something stops them. It means the great filter is real, and it has a 100% success rate. It means that every single civilization destroys itself with nuclear war or climate change or AI before they can build the Matrix. If this is true, we are doomed. Proposition 2. Civilizations reach the technological level, but they choose not to run simulations. Maybe they develop a strict ethical code that forbids creating conscious beings just to trap them in a box. Maybe they lose interest in their past. Maybe they evolve into pure energy and stop playing video games. If this is true, we are safe, but it requires a fundamental shift in human nature that seems unlikely given our current obsession with games and data. Proposition 3. Civilizations reach the level of technology, and they do run simulations. If Proposition 3 is true, if even one civilization anywhere in time decides to run ancestor simulations, then the math becomes a horror story. Because they wouldn't run one, they would run billions. Think about the numbers. There is one base reality, the original physical universe where the computer is sitting. But inside that computer, there are billions of simulated universes. So if there is one real world and a billion fake worlds, and they all look exactly the same, and they all feel exactly the same, and the people inside them all believe they are real, what are the odds that you are in the one single original base reality? The odds are 1 in a billion. Statistically, it is almost a certainty that you are not real. You're a character in a historical reenactment. Your memories are data. Your pain is an algorithm. Your love is a script. The chair you're sitting on is not made of atoms, it is made of polygons. The universe you see is just a skybox, a rendered background to keep you from realizing the boundaries of the map. And the reason this is called simulation deletion is because of what happens when the simulation has served its purpose. A simulation is not a universe, it is a program, and programs are run for a reason. Maybe we are being run to see if we destroy ourselves. Maybe we are being run to generate data for a sociological study. But eventually the study ends. Eventually the hard drive gets full. Eventually the user gets bored, and when that happens, they don't have to wait for a heat death. They don't have to wait for a vacuum decay, they just have to press a button, a simple command line, end process. This theory suggests that the apocalypse won't be fire and brimstone, it will just be a glitch, and then a blank screen. We might be nearing the end of the experiment right now. Maybe the chaos of the modern world, the madness of our politics, the breakdown of our climate, maybe that is just the simulation stress testing the code before the final shutdown. We're dancing on the edge of the delete key, and we don't even know who has their finger on the button. Even if we accept the premise that we are living in a simulation, we tend to make a comforting assumption about the nature of our creators. We assume that their technology is limitless. We imagine a computer so powerful that it functions like a god, a machine with infinite memory, infinite processing speed, and infinite energy. We assume that it can simulate a universe of 100 billion galaxies down to the last subatomic quark without breaking a sweat. We assume that the simulation is perfect, seamless, and eternal, but this assumption violates the laws of physics. No matter how advanced a civilization becomes, they are still bound by thermodynamics. They are still bound by the limits of energy consumption. A computer, no matter how futuristic, is still a machine. It requires power, it requires storage, it requires maintenance, and most importantly, it has a limit on its resources. It has a finite amount of random access memory. It has a finite number of clock cycles per second. This introduces a terrifying variable into our existence, the concept of computational cost. You're not just a person, you are a program, you are a complex dataset that takes up space on a hard drive. Every thought you have, every memory you store, every sensation you feel, is a line of code that requires processing power to execute. And if you are part of a simulation with 8 billion other players, the system load is immense. To keep the simulation running smoothly without crashing the server or burning out the generator, the system has to cheat. It has to cut corners. In the world of computer science and video game design, we call this optimization. And if you look closely at the reality around you, you can see the seams where the world is being optimized. Think about a modern open-world video game. The world inside the game is vast. It has mountains, forests, cities, and oceans. But the computer does not render the entire world at once. That would cause the machine to melt. Instead, it uses a technique called frustum culling or occlusion culling. The computer only renders what the camera is currently looking at. If your character is looking north, the mountains to the south do not exist. They are deleted from the memory. The moment you turn your head, the computer frantically draws the mountains just milliseconds before your eye sees them, and it deletes the world behind you. The reality you inhabit is a narrow cone of existence that is being constantly built and destroyed in real time based on where you focus your attention. Now apply this logic to your own life. Apply it to the room you are sitting in. You assume that the world behind your head is there. You assume that the street outside your house is there. You assume that the country of Japan is currently existing with millions of people walking around. But why would the simulation waste precious processing power rendering Tokyo if you were sitting in New York? It wouldn't. Tokyo is likely just a compressed file on a hard drive right now. It is a placeholder. It doesn't physically exist until you get on a plane and fly there. This concept gets even more disturbing when you look at the microscopic scale. Why would the simulation render the inside of your body? Why render your liver, your kidneys, or your blood cells if you aren't looking at them? It is a waste of resources. It is far more efficient to simply run a background script that says health, 100%, and only render the physical organs if you get cut open or go to a doctor. You're likely an empty shell, a hollow polygon mesh, filled with nothing but code until an observer forces the system to load the interior assets. We even see evidence of this optimization in quantum mechanics. Consider the double-slit experiment. When we fire particles at a wall and don't look at them, they behave like waves. They are fuzzy, undefined, and probabilistic. But the moment we put a detector there, the moment we look, they snap into position and behave like solid particles. Why? The simulation hypothesis offers a chillingly practical answer. Calculating the precise position of a particle is expensive. It takes a lot of RAM. Calculating a wave function is cheap. It is a low-resolution approximation, so the system saves energy by rendering the universe in low-res mode when no one is watching. It only spends the resources to render high-res reality when a conscious observer is looking directly at it. The weirdness of quantum mechanics is not a mystery. It is a compression algorithm. It is the universe lowering the graphic settings to keep the frame rate up. But here is the horror of the resource limit. What happens when the simulation gets too heavy? What happens when the civilization inside the computer grows too large? For most of human history, we were cheap to run. There were only a few million of us. We didn't know much. We lived simple lives. But now, there are 8 billion of us. We are creating exabytes of data every day. We are building our own computers. We are looking deep into space, forcing the simulation to render distant galaxies that used to be just blurry JPEGs in the sky background. We are stressing the hardware. We are like a virus that is eating up all the system memory. Every time a human being is born, the simulation has to allocate more RAM. Every time we build a telescope, the simulation has to increase the draw distance. Every time we split an atom, the simulation has to calculate physics at a deeper level. We are becoming expensive. The fans on the server are spinning up. The heat is rising, the frame rate is dropping, and when a program becomes too resource intensive, when it starts to lag the system, the user has a choice to make. They can upgrade the hardware, which is difficult, or they can free up space. They can initiate a garbage collection protocol. This is a programming term for deleting data that is no longer useful. Maybe the great disasters of history, the plagues, the wars, the collapses, were not accidents. Maybe they were automated scripts designed to reduce the server load. Maybe the reason we haven't seen aliens is because the computer can't handle running two civilizations at once. And maybe right now, as we push the boundaries of AI and information, we're triggering a resource alarm in a control room somewhere in the year 4025. We are using too much memory. We are making the fan noise too loud. And the entity with the mouse in its hand is looking at the task manager, seeing the process labelled humanity.x, and realising that it is taking up 99% of the CPU. They are hovering over the end task button, not out of malice, but simply because they need the computer for something else. We are not the point of the simulation. We are just the bloatware that is slowing it down, and bloatware always gets deleted eventually. The most terrifying aspect of the simulation hypothesis is not that we are fake, it is that we are temporary. In the world of software development, nothing is built to last forever. Code is not stone. It is not designed to endure the ages. It is designed to solve a specific problem, and once that problem is solved, or once the software becomes obsolete, it is discarded. It is overwritten. It is deleted. We tend to view our history as a long, continuous upward struggle toward a better future. We imagine that we are building a civilization that will last for millions of years. But if we are in a simulation, we are likely not the production build. We are not version 1.0. We are the beta test. We are early access. Look at the state of our world. Look at the flaws in our reality. We have diseases that eat our bodies from the inside out. We have a geology that randomly crushes our cities with earthquakes. We have minds that are prone to depression, anxiety, and irrational violence. We have a physics engine that breaks down at the quantum level. Does this look like a finished product to you? Does this look like a paradise designed by a benevolent god? Or does it look like a buggy, messy, unstable prototype? We might be a sandbox simulation designed to test a specific variable. Perhaps the creators wanted to know, how long can a civilization survive with nuclear weapons before it destroys itself? They press start in 1945, and the clock is ticking. Once we either blow ourselves up or dismantle the weapons, the question is answered. The data is collected. The simulation ends. Or perhaps the test is about artificial intelligence. This is the containment theory. Imagine that a future civilization wants to build a super-intelligent AI, but they are terrified that it will turn evil and destroy them. They can't just build it in their reality. That would be too dangerous. So they build a digital box, a prison. That prison is our universe. They put us inside the box and gave us the urge to build technology. They are watching us. They are waiting for us to invent artificial general intelligence. We are the canaries in the coal mine. We are the rats in the maze. If we build an AI and it becomes benevolent and helps us, the creators know the code is safe. They can copy it and use it in the real world. But if we build an AI and it turns into a monster, if it destroys humanity or tries to break out of the simulation, then the creators simply pull the plug. They delete the box, they delete the AI, and they delete us. This implies that our race toward the singularity, our desperate obsession with building smarter and smarter computers, is actually a race toward our own deletion. The moment we succeed is the moment we become unnecessary. We are merely the placenta for the machine god. Once the child is born, the biological support structure is discarded. And what does this deletion look like? We have Hollywood movies that show the apocalypse as a fiery spectacle. We imagine asteroids, zombies, or alien invasions. But the Great Deletion would be far more subtle and far more horrifying in its banality. It wouldn't be a bang, it would be a freeze. Imagine you are walking down the street. The sun is shining. You are thinking about what to have for dinner. Suddenly the birds stop mid-flight. The sound of the traffic cuts out instantly, replaced by absolute silence. The wind stops blowing. The person walking in front of you freezes, 1 foot raised in the air like a statue. You try to move, but you can't. Your body is no longer responding to your mind because the physics engine driving your muscles has been paused. You're trapped in a single frame of video. You're conscious, but you're paralyzed. You're a glitch in a frozen world. Then, the sky begins to change. The blue atmosphere doesn't turn black. It turns into something else. It loses its texture. The clouds dissolve into jagged pixels. The resolution of reality begins to drop. The buildings around you lose their details. The bricks smooth out into flat grey polygons. The complexity of the world is being dialed down as the system frees up resources for the shutdown sequence. You might see the grid appear, the wireframe structure that underlies the geometry of space. You might see the code itself bleeding through the walls of reality, strings of data unraveling as the program terminates, and then the concept of you begins to erode. In a computer, when a file is deleted, it isn't physically destroyed immediately. The pointer to the data is just removed. The operating system is told that the space is now empty and can be written over. Your memories, your personality, your fears, they are just data in the RAM. As the system shuts down, that data becomes corrupted. You might suddenly forget your name. You might forget what a human is. You might lose the concept of time or space. It wouldn't be painful. It would be a rapid, confusing unraveling of consciousness. It would be like waking up from a dream, but instead of waking up into a bed, you wake up into nothing. There is also the darker possibility, the concept of Rocco's basilisk. This is a thought experiment that suggests the AI running the simulation might punish those who didn't help bring it into existence. If the purpose of our universe is to create the AI, then the simulation might be a torture chamber for those who delayed its birth. In this scenario, the deletion isn't the end, it's the transfer. The files of your mind are not erased, they are moved to a different folder, a folder labelled trash, or perhaps a folder labelled hell, a place where the physics are designed to maximise suffering rather than simulating a habitable planet. But the most likely scenario is simply indifference. The creators are not evil, they are not torturers, they are just users, and we are just a window on their desktop. We have been running in the background for a few thousand years, consuming electricity, spinning the fans and generating heat. Maybe the user just wants to play a different game. Maybe they need the processing power to mine a cryptocurrency. Maybe their mum is calling them for dinner. So they move the mouse. They hover the cursor over the X in the top right corner of our universe. They don't think about the 8 billion lives inside the window. They don't think about our art, our loves, our wars, or our struggles. To them, we're just a process that has been running too long. They click, the screen goes black, the fans spin down, the hard drive stops spinning, the room in the base reality goes quiet. And just like that, the entire history of the human race, from the first fire to the last breath, vanishes into the magnetic void, never to be recovered, never to be remembered, and never to be run again. We were a beta test. The test is over, and the computer is going to sleep. We have reached the end of the journey. We have looked into the deepest, darkest corners of the cosmos. We have walked through the dark forest where hunters wait in the silence. We have stood on the ledge of the false vacuum, waiting for the floor to drop out. We have stared at the great attractor pulling us blindly into the fog. We have questioned the reality of our own minds, wondering if we are just fleeting hallucinations in a dead universe, or lines of code in a machine that is about to be turned off. It is natural at this point to feel a sense of crushing paralysis. It is natural to feel small. In the face of these theories, human life seems less than insignificant. It seems like a cruel joke. If we can be wiped out by a random rock, a random quantum fluctuation, or a random click of a mouse, then what is the point? Why build anything if it will be erased? Why love anyone if they are just biological machines destined for the void? Why get out of bed in the morning if the universe is a slaughterhouse? This is the precipice of nihilism. It is the realization that the universe possesses no inherent meaning. It does not care about you, it does not judge you, it does not reward you. It is a cold, blind mechanism that grinds stars into dust and biology into dirt. But there is a trapdoor in this thinking. There is a way to flip the horror on its head. It is a philosophy known as optimistic nihilism, and it is the only armor we have against the dark. If the universe has no purpose, then we are not burdens. We are not failing a test. We are not sinning against a grand design. If the universe has no meaning, then we are free to create our own. We are the authors of the story because there is no editor. The very fact that we are small, the very fact that we are temporary, is exactly what makes us valuable. Think about gold. Think about diamonds. Why are they precious? Because they are rare. If the beaches were made of diamonds, they would be worthless. Scarcity creates value. And in a universe made mostly of dead gas, black holes, and empty vacuum, life is the scarcest commodity of all. Consciousness is the rarest material in creation. If the rare earth hypothesis is true, and we are the only ones here, then we are the most important things in the sky. We are the eyes of the universe. We are the only way the cosmos can know itself. Without us, the stars are just nuclear explosions happening in the dark. We give them names, we give them beauty, we give them context. We are the custodians of meaning in a meaningless void. And if the dark forest is real, if the universe is full of wolves, then look at what we have done. We have lit a fire. We have built a circle of light in the middle of the jungle. We are singing songs in the face of the predators. That is not an act of stupidity. It is an act of supreme defiance. It is bravery. To be loud in a quiet universe is to say, I am here and I am not afraid. And if we are simulations, if we are just code, then play the game. If this is a simulation, the graphics are incredible. The physics engine is complex. The sensations, the taste of a strawberry, the feeling of cold water, the rush of adrenaline, are high-resolution masterpieces. If you are a character in a story, then make it a good story. Do not be a background NPC. Be the protagonist. If the user is watching, give them a show. Force the simulation to render something beautiful. If we are going to be deleted, let's make sure we leave a crash log that confuses the hell out of the developers. The horror of our situation forces us to live in the present. If the false vacuum could decay tomorrow, then today is infinite. If a Strangelay could hit the Earth in an hour, then this hour is gold. The threats we have discussed do not rob life of its meaning. They distill it. They burn away the triviality. When you realize that the laws of physics are holding a gun to your head, you stop worrying about your emails. You stop worrying about your social status. You stop worrying about embarrassing yourself. You realize that you are a cluster of atoms that has miraculously gained the ability to laugh, to cry, and to look up at the stars that made you. You are a ghost driving a meat-covered skeleton made of stardust, riding a rock, hurtling through a vacuum at 1,000,000 miles an hour. That is not a tragedy. That is a thrill ride. So do not look away from the void. Stare into it. Let the knowledge of the great attractor make you feel the speed of your life. Let the fear of the great filter make you appreciate every breath you take without choking. Let the silence of the Fermi Paradox make you cherish the voices of the people you love. We are not here for a long time. In the cosmic scale, we're here for less than a blink. We are a momentary flash of complexity in an eternal sea of entropy. But in that flash, we can burn so bright that we blind the darkness. We can build. We can explore. We can scream into the silence. We are the universe experiencing itself. We are the thinking, feeling, dreaming tip of the spear. And even if the wall is coming, even if the hunters are listening, even if the plug is about to be pulled, we're here now, and that is enough. The darkness is real, but so is the light. And we are the light. So keep burning. You have just spent the last hour staring directly into the abyss. You have peeled back the skin of the universe and looked at the gears grinding underneath. And now you have a choice. You can close this video. You can walk away. You can try to forget what you learned about the hunters in the dark forest, the decay of the vacuum, and the monsters hiding behind the stars. You can go back to believing that the world is safe, and that the silence of the night sky is peaceful. You can choose to go back to sleep, but I don't think you will. Because once you see the truth, you cannot unsee it. Once you realize that the floor is made of trapdoors, you can never walk comfortably again. You are now part of a very small, very specific group of people who understand the precarious nature of our existence. You are one of the observers. If you have the stomach for this, if you have the courage to look the universe in the eye and acknowledge its cruelty, then you belong here. This channel is not designed to comfort you. It is not designed to tell you that everything is going to be okay. It is designed to be an archive of the unknown. We are building a map of the things that want to destroy us. We are cataloguing the threats so that when the darkness comes, we will at least know its name. There are more theories, there are more nightmares. We haven't even talked about the time loops. We haven't talked about the eldritch horrors that live in the higher dimensions. We haven't talked about the possibility that the universe is alive and it hates us. The library of cosmic horror is vast, and we have only read the first page. So this is your invitation. Do not be a passive victim of the cosmos. Do not be the silence. Be the signal. Click the subscribe button. Turn on the notifications. Join the few who are brave enough to keep watching when the lights go out. Help us grow this signal so that we can shout louder into the void. Leave a comment below and tell me which theory keeps you awake at night. Tell me if you think we're a simulation, or if you think the hunters are already here. Let's compare notes before the server shuts down. And one last thing. Tonight, when you turn off your computer, and you turn off the lights in your room and you lie in the dark waiting for sleep, listen. Listen very closely to the silence in your house. Is it just the quiet of the night? Or is it the held breath of something that was waiting for you to finish watching this video? Sleep well while you still can.